A very good morning, Ahmedabad. Good morning, sirs. Thank you. That's very nice. Zak World of Façades, the third edition in Ahmedabad. And the series worldwide, this edition is 212. A big hand, please. I will complete my welcome address in 2 minutes, 2 to 3 minutes, and then I'll have Mr. Shah, Shalin Shah, take over as the host of today. Zak World of Façades, which is one of the most sought after series of conferences worldwide. These are our event lineup for 2026. Tirana, Brisbane, Melbourne, Calgary, Vancouver, Toronto, Limassol, Cairo, Tbilisi, Ahmedabad, Chennai, New Delhi, Mumbai, Rome, Kuala Lumpur, Rotterdam, Manila, Warsaw, Lisbon, Riyadh, Barcelona, Istanbul, Bangkok, Dubai, Manchester, London, Washington, Los Angeles, Phoenix, Dallas, New York City, San Francisco, and Tashkent. There is more demand, but I think with the human capacity, we are able to do only 42 events in a year. Thankfully, with the support of our people, when we started this from India, and we are proud to say that this is the only conference worldwide who have completed 212 conferences on facade industry from India by an Indian organizer. A big hand to Mr. Syed Ahmed, who conceived this concept and who is successfully running around in Calgary today. So everybody is asking, where is Ahmed? -9 degrees with full active snow through the conference, but still delegates come. In Ahmedabad, the delegates are yet to come, and it's 11 a.m. in the morning. This is Ahmed now at Calgary, Canada, today. Next, please. Zak at CGY. A big hand. Next, please. Our presenting partner for this event in Ahmedabad is Shuko, Aluplex, powered by this event, Cotswold, Dow Corning, Dow, Eminent International, Fundamax, Glacium Facades, GU, Innovators, IPH Glasses HiFab, Jotun, Curare, Qtone, Rhina Industries, Siderise, Viva Composite Panels. And since we don't have Zak World of Façades in Bangalore this year, which we have shifted to Chennai, we have come out with a new concept, a consolidated of glass, doors, windows, facades expo in Bangalore on 28th, 29th, 30th of this month, which has turned out to be extraordinary. And we have more than 120 plus brands participating in Bangalore Exhibition Center. And of course, our supporting event, which is Glass Technology Expo, Doors and Windows Expo, and Aluminium Extrusions Expo, from where this Zak World of Façades was conceived. With these people supporting us, this main event is going to take place at Yash Bhumi, New Delhi, from 10 to 12 December. Plan your dates. Next. This is the lineup for the event in India. On Chennai, we have on July 17th, New Delhi, we have on August 27th, and Mumbai in October 23rd. Now I request Mr. Shalin Shah to please take over as the host of today's Zak World of Façades event. A big hand for Mr. Shalin Shah.
First of all, thank you, Zak sir, for an amazing introduction. So good morning, Ahmedabad. Good morning, Ahmedabad. This is not Ahmedabad's good morning. Good morning, Ahmedabad. That's more like my Ahmedabad. So, ladies and gentlemen, please welcome to third edition of Ahmedabad and 212th edition of Zak World of Façades. So, here we are going to see all the developers, architects, facade consultants. So basically, we are the people who are going to shape the city's skylines, right? So whenever we go to a city, it is known by skylines. So all the dignitaries over here are going to contribute a lot to Ahmedabad's skyline. So I'm more than grateful to have you people over here. And let's hope, let's together create a great skyline for Ahmedabad and let Ahmedabad be recognized for its skyline. So my name is Shalin Shah. It's an absolute privilege to be your host today. I work as a sales director at IPH Glasses. So we have been a part of city's fabric for years, focusing on high-end performance technical glasses solution from complex insulating units to safety glazing. We live up the challenge to making up your architectural vision structurally sound and energy efficient. But today, I am here to ensure you have an insightful, seamless, and high energy experience. Okay, guys. For the event, there are two things which are most important in today's time. So can anyone tell me what are two things which we are missing today? We have all the resources, but we are missing on two things. What it is? Anyone can take a guess? Okay, so I think the biggest problem what we have is attention span. So we have a lot of problem in attention span. We do miss on important things. So guys, it's a simple request. Please try and be away from your phone. Try to keep it on silent. Try to silent and keep it upside down so we don't miss on the important event. And the biggest thing what I see is time. So I request all the delegates, speaker, everyone over here to be very precise on the time because the time is the most important thing. We are in Ahmedabad. Time is money, right? So let's try and be on time. We try to finish each and every presentation on the time. Thank you. And last thing, for the people who are here, our speakers are ready to take questions and answers, but that is during the network session, not during the speech or not during the presentation. So please be mindful that you will be allowed to answer, your question, but that would be during the networking session. Thank you so much. So our first speaker of today understands the intersection of form and function. He brings together forms and functionality in an amazing way. So please give a warm round of applause to Mr. Raman Aras from Studio ARA. We are looking forward for an amazing presentation. Thank you, Raman.
Hello, everyone. I'm Raman Aras, founder and principal architect at Studio ARA. When we were first presented with the opportunity to speak here, we were wondering what should be the theme. So then I thought it would be best to talk about, as a young practice, about our thought process, shared experiences, learnings in two of our key projects. First, a quick introduction. Studio ARA is a 10-year-old firm. We are a small group of designers that have had the opportunity to work on projects of varying scales and typologies. We strongly believe that design is a collaborative process, and we work with the best experts in the industry, depending on the requirements of a project. We have worked on small projects as small as a few thousand square feet to more than about 1 million square feet in built-up area now. Today, I will talk about these two projects, 142 and Flex 1. So starting with 142. 142 is just located off Amli Road in West Ahmedabad, which is now a hub of premium retail stores and offices. The project comprises of 2 office towers, a street-facing retail block arranged around sort of like a central courtyard. This was one of our first projects of this kind. So it was sort of like heading into the unknown. And the project itself was a first in other aspects. It was the first of its kind in Ahmedabad, where the developer wanted to make a truly A-grade building with top specifications. It was the first to be done entirely in BIM, first of its kind to have actually a facade consultant and a well-experienced facade contractor. All people who wanted to make a landmark building more than anything else. Now, this was made possible, and I speak, of course, in retrospect, due to the collaborative interactions between client, architect, that's us, and other consultants. See, as an architect, we might be in the best position to have an overview of the design, the functional, the technical, and the aesthetic. But the consultants, contractors, they have a wealth of knowledge and experience. And at times, there's only a one-way interaction where the consultants are limited to only enabling the architect's design ideas. And they might not be well thought through at times. So we love to work with consultants, with contractors who will not hesitate to point out the potential flaws in our designs, because it's all in the interest of the project finally. So we believe design has to be collaborative and a democratic process, else the designed buildings will look good only in year one. And then it all falls apart bit by bit. And of course, by then it's somebody else's problem. That's what, usually we think. So we'll start with a short video. This is, sorry. This is year 7 of 142. We believe that our buildings are a mark of our cities and that excellence, robustness, resilience must be built into the design. Facade is basically all the external faces of a building. It is the entire external articulation of the built mass of what is inside. For us, it comprises of openings, opaque surfaces, solar shading, weather shades, signage, paving, greenery, etc. All that come together to define the look of the building and the experience. So starting with the offices, we have these two towers, north and south tower, which are perfectly aligned north-south direction. That's the layout of the typical floor. Essentially, there are two half floors, about 500 square meters each, and the vertical circulation core is in the middle. We wanted office spaces that were flexible and had adequate natural light penetration. Each half plate is further divisible into 3 units, smaller units, if that was a requirement. And each unit would have access to space for outdoor AC units. And this was part of the design right from the beginning and part of the facade design. It was never an afterthought. That's a close-up view of the facade. We used high-performance DGU in the glazing with solar shading fins made of tensile mesh membranes. This created shade without compromising on the view from inside the offices, because the facade is, fine, it's all good to look at from outside, but the view from inside should also not be compromised. So the mesh helped us do that. It also helped reduce the wind load, so the fixing mechanism could be less heavy, it could be lighter. And the fins were designed as a simple system whereby each fin was individually installed. So in terms of maintenance and replacement in future, it would be very easy to do that. The opaque surfaces were clad with a granite that was procured from nearby area and finished in linen river wash to complement the Ahmedabad climate. We did have the option of choosing another granite from a faraway quarry, which was cheaper and possibly better looking. But as our client pointed out, sustainability is first about reducing the footprint. So we went for material that was more locally available. When we talk about sustainability, unfortunately, we tend to always fixate on energy efficiency, and we don't think about the other aspects. The AC ledge areas were covered in Z louvers from Hunter Douglas, as it allowed efficient airflow while camouflaging the internal units. And as you can see, there are no horizontal surfaces anywhere in the facade. This was deliberate because we wanted to minimize spaces where pigeons could roost or perch. And everyone talks about water when it comes to facade, but I believe not enough attention is given to pigeons and dust, which is equally important because how the building performs depends on all these factors. So this is an overall view of the facade showing how the shading fins actually work. This is in summer. And in winter, the fins allow more sunlight in, and when the light is softer and weaker. And in the evenings from outside, they almost disappear, they become minimal. Moving on to the retail block, it was designed to create the experience of high street retail. Now, so much of retail shopping is about the experience. You can buy almost anything online. But being there physically, it's a whole new experience. To be able to walk through an interesting environment with many possibilities, that's what we wanted. The retail block has multiple entry points and vertical circulation cores which allow for flexibility in movement. And the backside units open into the central courtyard. That's the overall structure. We designed it as a series of blocks that stand out individually but have an overarching common identity. In our heads, the mental image of the destination for a shopper had to be stronger than any individual unit. People had to think, we want to go to 142, not to this shop, and oh, that shop is in 142. So for us, that was important. And the facade played an integral role in creating this identity. This is just a section which shows the connection of the street to the internal spaces and to the central courtyard behind. Now, looking at the retail facade, a part of it, one wonders how many agencies it would take to execute this. It sort of sounds like how many people it would take to change a light bulb. So let's see. You have the traditional facade contractor who does the glazing, ACP, and the aluminum works. Then we have the stone cladding agency. We had some exposed concrete elements, so the civil contractor was doing that. The shaft coverings were a Hunter Douglas system, so that was a different agency. We had some other elements that needed a fabricator. We also had to look at the flooring because the flooring always has an interface with the facade in this sort of a building. And if all of that was fine, there was still the tenant who could do something unintentionally and damage the look of the building. Now, all these agencies played a role in the facade. So then how do we determine the performance of the facade? Each agency submitted shop drawings for their own scope of work, which was great. But there was no overlap. So as the architect of the project, we decided to collate everything, covering details of every corner, every junction, every typical and non-typical part of the facade. This amounted to over 50 separate spot details. And we worked collaboratively with all the agencies involved. And this gave everyone, especially the client, great confidence that all the areas of concerns were addressed. And this also helped establish the sequence of work because there were so many agencies involved. So who comes first, who does what? Just some examples of the details. And like I said, all of this would have been in vain if not for this retail signage policy. So this was virtually unheard of at the time. Typically, tenants, owners, when they assumed ownership of a unit, they thought the external facade belonged to them and they could do anything with it. So we helped create a document that detailed out the signage for each unit, where it would be, how many signages per unit, sizes, other details, and with multiple examples. So it would be clear to the tenants what they could do, what they could not do, and at the same time not be too restrictive. These are some pictures of the retail block now. This is in the early morning. Some of the details, some close-ups. The recreational terrace with the greenery on the top. And it's a vibrant, busy hub in the evenings. So yeah, people in Ahmedabad would know that. Now, projects of this sort, or this scale rather, have always a substation, a requirement of a substation, which is important, functional, and perhaps unwanted because it interferes, for designers that is, because it interferes with the experience, the planning of the project. And so it ends up being exiled to the periphery of the project, to an unwanted corner. Well, we thought of it as the engine that powers the building and reimagined the design of the structure as a kind of a large heat sink that creates a visual anchor in the plaza with a stage that can act as a backdrop for gatherings and events. And you get a glimpse of it from the offices as you move through the retail block. Some other angles. So moving on to Flex One, our second project. So this project is in Gift City, and Gift City is conceptualized as a truly world-class city with matching infrastructure. It has many buildings that are already up and running, and still many more that are, under construction. But when we started work on this project, this is how Gift looked, And in such a scenario, we wondered, how does one approach the facade design of a building? Each building takes about 3 to 5 years from conceptual right up to building occupancy. And the surrounding development may take another few years. So the question was, how do we make something that is still relevant in the time to come? We needed a design which had a timeless quality, something that would endure and stand the test of time. So we began the design in 2021. Construction, the red dot is where the project is, by the way. In 2022, the construction also had to start in parallel. And you can see in 23, development already started in other areas, other projects, they started work. And by the time our project got completed in 25, and, plenty of other developments had started, and Gift is right now a massive construction site. It's, everywhere you go, there's just a project coming up. So there's a lot of energy that is there. Now, back in 21, we had more or less anticipated that, by the time our building gets completed, it would be like this. So when we had started the design, we thought the facade design should be governed by the following aspects: timelessness, longevity, and minimalism. This, in our opinion, would keep the design language relevant in the coming years as the city takes shape, and wouldn't make it look dated. See, you may have an idea of how a building looks now, but 5 years, 7 years down the line, when it actually comes up and the rest of the city looks different, you may find that the building looks dated. So for us, it was very important that the building, stand the test of time. And this building was to be leased. It was not to be sold. So longevity became one of the central themes. The building had to look just like day one, more or less, in 10 years' time. So the guiding philosophy was a famous line, less is more, and the more obscure, less but better. Basically meaning attention to details. Something with crummy details falls apart relatively easily and sooner. Good details age well. Good details are a mark of refinement, sophistication, and maturity. The sign of refinement is in the details, whether it is the slight chamfer on the edges of this phone, which is functional, but also catches the light slightly differently. Even the nuts and bolts can be engineered in a way that they be visible, but add to the aesthetic. And branding can be as subtle, but as iconic as this classic mechanical pencil with the red ring. Coming back to the project, typical floor plans of this building were optimized for large offices, and again for natural light penetration, essentially divided into two halves with the possibility of a connection in case of a single occupant scenario. But there was no real requirement to have different kinds of floor plates, to carve out volumes, have slants in the building, so anything like that. There wasn't any such requirement. And we thought breaking up of the form just to create interest would only complicate issues with design of the facade, execution, and maintenance in the years to come. So we decided to be true to form follows function, or rather facade follows function, and go for a machined look for the building. So talking about the build form, we started with the building envelope. Due to the proportions of the building envelope, we made vertical divisions so that the building appeared taller. The central bit which connected the two halves on typical floor could have some balconies or breakout spaces. We thought of having a division every 3 floors so that gave the building a more scaled look. And this we imagined could be like a groove. And the four corners of the buildings, we thought, could be chamfered, and they would catch the light. And as we look at the building from different angles, it'll look interesting, and it'll give a finished look. And at the ground level, we thought a grand entrance lobby, lounge, amenities as a podium structure would create a visual anchor, and that is where it would make the most impact, at the ground level, eye level. And finally, a crown on the top that would sort of, cover the lift, machine room, the tanks and everything, and act as a, sort of crown. While we were looking at, solar shading and everything, we also realized that the rear facade faces southwest, and that's where, it could do with some solar shading. So we modeled a few of the adjoining buildings, some which were not there, but which would come up in the near future. And we realized that, some of the upper floors in the back, they didn't get shade in some of the critical hours in the summer months. We also did few other simulations to figure out how deep the fins should be and how they could be different on lower floors versus upper floors. Okay, let's now look at the actual project in a short video. Okay, we are almost at the end now. I just need a couple of more minutes. I would like to share this experience of the podium canopy because it was, an interesting bit of the project. It was a fairly simple design, or at least I thought so. We needed a canopy that stuck out like 6 meters, but we could not put any column because there was a drop-off area below. So we worked with the structural engineer and came up with a system of trusses, space frames that allowed us to do this. And they were functional, but also created an aesthetic around it with inclined columns. And when it all started coming together, it was still very difficult to visualize how it would finally turn out. We made 3Ds and everything, yes, but in reality, when it looks like this, you really can't tell. And the scaffolding was there right till the end. People were above the scaffolding, they were doing the ACP work, and you couldn't tell what they were doing. This from the front side. Till one evening, we had gathered at the site to look at the interior works, and they had removed the scaffolding that evening. And we got our first real view of the canopy. And what a sight it was, to see the crisp forms, the sheen of the metallic finished cladding, the joints so well done. It was truly a collaborative effort of people coming together, each doing their bit. And as architects, we may draw many things, but this moment is what it all really boils down to, seeing it come up like this. So that's Flex 1, everyone. Thank you for your patience. Just a quick preview of a few of the projects that are coming up. So this is Oryx at Gift City, which is going to be finished hopefully in early 27. West Ham, which is in Ahmedabad in mid 27. And Massimo at Gift City, which will be longer, 29-30. And yeah, that's it. Thank you. And sorry, I had to put this because my partner said, we are looking for young architects, and if anyone is interested or know somebody who's interested, please do reach out to us. We would love for you to join our team. Thank you, everyone. Thank you very much.
Thank you, Mr. Raman. That was actually very insightful. And thank you for making us part of your wonder buildings. We are so happy that we could work with you on these buildings. So right from envelope, right from the structure of the building, we move to the skin of the building. Please give a warm round of applause for Mr. Ashwanii Khanna from Fundamax. Thank you.
So before getting into thick of things, like Those who know me, they know me that I will start with Menti always. So I request everyone to please open menti.com on your phones. Or you can also scan this if it is possible to do it from your angle. I request everyone to participate, please. It would be interactive because this stage is always alone. I don't want to be alone. I want everyone to participate. So, first question is, someone has not given a... Okay. What best describe your primary role? Architect is getting bigger here. So many people have said architect. Curious child. Project management. Project management architect is getting bigger. I'm sure there are a lot of facade consultants and facade fabricators also in the room. Engineers, planning, facade, safety, curious child, procurement. Procurement guys are also here. Yeah. Thank you for your response. So far, 39 people have responded. We'll move to the next topic now. How confident are you about integrating fire-safe rear ventilated facade in high-rise building? Not confident, extremely confident. Yeah. Yes, as a together group, we should understand what is the concern. Why are we not confident? Maybe my presentation is also able to throw some light on it. Good, I can continue with my presentation because many people are not confident designing the facade with the fire topic in mind. Rohan sir, based on the feedback, I changed the questions. When you think of facade fire safety, what is the first word that comes to your mind? Emergency exit, insulation, yeah, safety is the concern. I can understand. Someone has written unsafe, so there the concern is the safety. Next question is a bit tricky and it will take time. So I'll skip this question. I'll move to the last part. So what one action would you improve, would improve facade fire safety? Yeah, do not panic. Awareness, rail, proper design, insulation, safety, easy access, awareness. Awareness is very good topic, yes, I understand. Detailing, commitment, proper planning. Yeah. Thank you all for your participation. I will share this feedback to the Zak team as well so that they can share it with all the audience. Now I'll move to my presentation. So, I'm Ashwanii Khanna from Fundamax. Our topic for today is cladding for high-rise building, a rear ventilated facade. We are also going to talk about Class A and Class B panels from Fundamax and some custom applications which are possible. So, what is rear ventilated facade? It's actually creating a cavity between the wall and the cladding so that there is a continuous airflow. In hot summer like in Ahmedabad, hot air will start to flow from the bottom of the panel and will exit from the top of the panel, thereby giving heat insulation, sound insulation, reducing the load on HVAC. We can even work on payback analysis that how much saving is done on the HVAC or other parameters after doing rear ventilated facade. Thermal insulation, sound insulation, all these are the benefits of rear ventilated facade system. Now, how do we classify fire? We normally look for these kind of symbols on the fire extinguishers when there is a fire. Class A is originating out of normal wood, paper, or any other solid material, and simple water is also good enough to extinguish the fire. Class B is flammable liquids. Water is not good to extinguish the fire. We look for B logo on the fire extinguisher. Similarly, C is arising out of electric wires, some short circuit or something. D and K is not of our interest for today's discussion. Similarly, the materials are also classified as A1, A2, B, C, D, and F. So from Fundamax, we have A2 class material and B class material. We will discuss these two material in detail. Whereas other material which are commonly used are also mentioned on the left side of the table. For example, concrete is non-combustible, it is A1. Similarly, brick is also non-combustible. Now, when we talk about A2 class material of Fundamax, it is known as MLOOK. MLOOK is non-combustible material for Fundamax, which means it does not cross the ignition temperature. Then our standard product is class B. We do our 96% or 97% of our sales in class B material. This class B material will not cross the flash shower point. It will cross the ignition point, but it will not cross the flash shower point, which is very important for any fire protection. What does it mean actually? It means that it will not develop into a full-fledged fire. So it is very safe to use in high-rise buildings. Now the question can come, if we use it in high-rise building, and we have also spoken about rear ventilated facade system, what if the fire will spread from the cavity between the panel and wall? Okay, we will talk about it. But before that, there are some tests which we have done. As per ASTM E84, it is class A, and flame spread index is 10, and smoke developed index is 95. And similarly, for EN standards, the classification is BS1D0 for max exterior and BS2D0. So it varies because of the thickness of the panel. For 6 mm, the smoke index is S2, and for 8 mm, smoke index is S1. And for MLOOK, it is A2S1D0. We have also done NFPA test, and we have the report for that as well. This is a real project. This is how the Fundamax panel behaved in one of the project actually. I cannot show the full image of the project because we don't have NOC for that. But if you see, the cladding is intact. The fire did not spread on the left side of the building where the decor is properly visible. And here the system was also completely integrated. There was no system failure as well. Rivets are clearly intact. And when we removed this panel and reversed the panel, the other side of the panel was intact. The decor paper and the surface was totally intact. We suggest using fire stop so that fire does not spread from the cavity because we are leaving the cavity. In case of fire, this fire stop will expand and create the compartment. So fire is restricted to the compartment, thereby blocking the fire in that particular compartment, and does not rise to the other floors. So it's restricted to that particular floor. Can anyone tell me what is this actually? This is the recent fire accident which happened in Vadodara yesterday. My colleague was actually in Vadodara, and we could see, and there were at least 10 fire tenders trying to extinguish the fire. There were some droplets. Droplets can cause secondary fire. This is not a good news for us as well as the entire industry. I would request you to please study in your free time what happened in this particular topic. Some of the projects we have done in high-rise, this is from the Ahmedabad itself. This is Cloud 9. This is in Bangalore. This is 21 floors building. This is ONGC project in Mumbai. This is also one of the high-rise we have done in Bangalore. This is in Chennai. This is again Mumbai and project in Noida. Again, project in Noida, and right side is Antilia, Mukesh Ambani's residence. We can also do double skin facade, thereby giving thermal and visual comfort to the occupants. It looks like a normal facade, but you can make it like louvers so that, that provides you sun shading. This is Ahmedabad University. This is one project we have done in Lucknow. It's again double skin, a skin in front of a glass, acting as a shading device. Horizontal or vertical louvers are also possible. The louver angle can be decided based on the sun path analysis. Thank you. Let's get connected, and we also have a booth outside the hall. We are here to network with you.
Thank you, Ashwini. That was actually very insightful. So people are going to take care of fire more in the way they build the buildings now. So next joining us from Mumbai is Mr. Suresh. He is an expert in facade consultancy. So let's welcome Mr. Suresh. Thank you.
I've come here to speak on timeless facades, which basically is a new topic. And when I heard about this topic, I thought of architects who are challenged to design buildings which can actually, be timeless in the modern world. You're forced to design buildings with a certain time, less of material options, less of, inputs in terms of many factors. Many factors come in terms of supply and, deliver. So I think that is what the topic is, and I wanted to start about, talking about facades which can actually give a timeless feature to the building. And it doesn't have to be the whole facade, but it could be elements in the building which can be, like a memory point for the people who view it. So this is a facade which is in Manhattan, in New York, and this was actually torn apart by MoMA because they wanted to extend in the space. So there's a platen cast bronze facade which was handcrafted and installed, and you could see that people would actually get into the building and they would like to touch when the barricades were open. So that was the main overwhelming point of the architect. He stared and looked at when it was open. When this museum was opened, he was basically looking at it, and the people were going and touching the facade. So what we basically look at is organic surfaces. So if you look at a monolithic, monochromatic facade, it is basically flat. It's like extrusions or flat sheets. But when you look at organic surfaces, you need to either cast it, or it could be a material which could be natural. So that's what it is. And in modern world, what we generally do is architects tend to use technologies and ideas which can basically make it, maintenance free. So if you look at all these joints, they're open joints, which basically doesn't allow, if you put silicone in a joint, what it does is because of the high coefficient of friction, it starts staining and it will start streaking. So you generally don't use, in these facades, you never use a silicone and you don't seal it. You generally leave it open, and it has a rain screen principle where it drains out the water. And if you look at all these textures, these are basically, every panel is different. Every panel is unique. There is no panel which is similar. So this is the view of, anybody who goes to the building, they look up, this is what they see. And this you can't get in a normal, in a standard commercial building or anything. It will be a texture which is totally unique. And if you look at the right-hand side, it basically is the same texture in concrete. So you basically cast it in concrete and get the features. So everybody knows this material. It's cotton steel. But some clients, they embrace the idea of oxidation. They expect that, it is going to oxidize. It's going to stain the floors, but they're still comfortable with that. They want to use that material because it's ageless. After maybe 50 years also, this will remain like this, which you want, and it'll be different. It's a different, unique facade where you don't get the same texture, you don't get the same monolithic feel of it. So this is how it is, and this will look different every year. Every year it will keep on changing. So this is for YSL where, again, this was the Horseman architecture, wooden panels, wooden crafted, panels were used. So what they did is they basically changed all the wooden crafted panels into a white bronze cast. So, and plus it's a rain screen, plus the joints are not sealant. And this basically gave a little bit of a, it gave the flagship store identity in that lane. And if you look at it, the bronze was made in such a way that, if somebody walks past that showroom, they'll see the glinting of the fabric. If you're walking in a blue shoes or red shoes, or, you're walking in a blue safari suit or something, it will basically, it'll give you the reflection on the bronze. So there's another, it's a flagship store for Dior. But here, it's more to do with, your texture on the material. So there's a FRP panel, but it could be a normal FRP panel. But what they did is they gave a texture which is basically seen from 3 meters away from the facade, which basically gives it a fabric feel, which is the Dior's landmark. They want to show that. They want to replicate that. So this is the texture which is given, but this is what architects do is they give a feel on the materials which can actually emphasize the timelessness of the facade. That's what is the main goal for this. Now any building, it has to look good in the night and day. So here what has happened, what the architect has envisaged is folded plates which gives it a timeless facade in terms of daytime and nighttime. So if you look at this is the facade in the day, and that was the facade in the night. But if you look at the folded plates, it was crafted to, in a unitized system to be installed on the facade. It's quite tricky, but that's the feel of it. This is Thapar University where sandstone was used in a very articulated way. They're jalis, but they're more contemporary, but they basically have all the features like a jali, which is provided, but the jali is in a very conventional way, where it's just a plate where you have tension compression rods. This is the inside view, and this is the format. But it's got glass, and the architect actually envisaged that the glasses can be replaced from inside, rather than have the frame from outside. So again, architecture can, there's a CJ Blossom in Seoul, Korea, where it is 3 towers. Now it's like a ribbon. It's a screen which is basically enveloping around the building, and it's actually taking care of it's making it more parametric, and it's making it more unique in terms of a ribbon shape. And all these support structure were designed in such a way that you don't have, if you look from inside, it's basically a very sleek profile, a substructure. So these are 3 towers and it's all linked like a ribbon. This is the East Asian Library. Again, timeless architecture is all about how and what you want to see after 50 years and how does the material retain its shade and retain its texture and all that. So this is basically a cast bronze screens, which has got, it's a East Asian library, so it's got the same fabric of a East Asian, and it's got a rectilinear lattice pattern. And it's got a shading system mechanism where, you got, it's a shading device, plus it also, allows filtered light to come in. This again using limestone in a very crafted way. So you have all these reveals were made in such a way that you got stainless steel which reflects the light, but you got the stone pattern which is basically a rain screen, and it's installed on the facade. And especially in the night, you want this is like a lantern. It's a lantern which is basically lit up, and it's all laminated glass with with a translucent film. Thank you.
Hi, let's give it all to welcome Mr. Rohan Keswani from Aluplex.
So good afternoon, everyone. Just about afternoon. So today I'm just going to talk about different smart skins, talking about projects. Today's commercial landscape is more about not just aesthetics, it's about sustainability, it's about using different materials, as Suresh spoke about, it's about having different shading devices and shading methodologies, as Raman spoke about. So I'm going to talk about a few projects and about the way we go about achieving those different factors, which is aesthetics, which is different materials, different textures, different shading components to reduce the overall carbon consumption and the embodied carbon as well as operational carbon in the building. So before I talk about my presentation, talk about who we are. We are Aluplex. We've done more than 500 projects in the IT, commercial and high-rise residential space. Going back one slide. In today's commercial landscape, talking about Ahmedabad and Gift City over here, we did Gift City's first project, which was back in 2014, done in a very short period of time for ILNFS. And also we worked on a project with actually Suresh, in fact, which is the Shapat 5 Crown Plaza Hotel, which was actually Ahmedabad's first unitized glazing project at the time. Still standing today and still looking good. So, that was, I think, also 2010 or 2011. Today we're working on other projects as well in Gift City and other parts of Gujarat as well. So talking about, as the commercial landscape is changing, we have different materials. People want to use different shading devices. I spoke. People are looking at different materials, looking at bamboo, looking at wood, looking at stone, to sort of not have just a glass block as a commercial building anymore. And to talk about this, I'm going to go through a few case studies. One case study is the Platina building, which is in Bandra Kurla complex in Mumbai. Now, this project, as you can see, incorporates curved glass right in the middle. It's at a corner plot in a very prime location in Mumbai, in Bandra Kurla complex. They say that Gift City is the BKC of Ahmedabad. And what we've used over here is a curved performance glass, but also use a very interesting shading device. As you can see, the shading devices on the sides of the building we have developed this indigenously. We have used the facade system is spanning from floor to floor, but on that particular individual floor, we have, there's no pointer here, right? Okay. So we have, there is this up button, right? Okay. Oh, okay, fine. Something like this? No. Okay, fine. There's no pointer. So going back is basically you have, as you can see, is we have this particular from the slab level, we have a plate which is coming out, and that plate is connected to an actuator mechanism which gets connected to the sun shading devices. We have these aerofoil fin louver system over there. The aerofoil fin louver is about 450 millimeters in depth, and based on the angle of attenuation of the sun and the control system that we are incorporating within the building, we are able to control the angle of incidence. We're able to control the angle of incidence of the sun shading system. Another project I'm going to talk about is the Godrej 1 building, which is in Mumbai. This is the headquarters of the Godrej Group. You have Godrej Properties there, Godrej Industries there. And this project incorporates a lot of different elements, which is not just the typical box structure of a facade or a commercial building. As you can see on the outside over here, we have stone-clad sunshades. We have sunshades. We have integrated stone sunshades onto the unitized curtain wall, 1.2 meters in depth, which are cantilevering off the mullions of the unitized system, supported onto the unitized curtain wall. Within the atrium, we also have a completely unitized curtain wall system, but we have wooden slats and sound-absorbing wooden panels in the spandrel panels instead of glass, in order to ensure there's less echo and better sound acoustics within that particular atrium. Separately, we also have a very grand atrium glazing, which is a 50-meter height atrium, which is 11 floors in height, which has bridges, etc., within that atrium itself. So the first is the stone sunshade. As you can see, is we have this unitized curtain wall system, and we have a stone sunshade system. It's a 1.5 meter wide by 1.2 meter deep cantilever sunshade, which is anchored to the mullions of the unitized curtain wall, thereby, not having any piercings through the facade system, having no piercings through the seals of the building, and we have designed the mullions accordingly, designed the bracketing system accordingly to withstand these particular loads. This is how the building looks. You can see the stone sunshades, how they are fixed onto the particular unitized panel to give you that look of a, not just a simple glass box system. The other important part I was talking about, as you can see, this is the internal atrium. So the whole facade has an external facade where you saw the stone sunshades, and it also has an internal atrium. Now in this internal atrium, we also have a unitized curtain wall system, which was installed on the edge of the slabs with cast-in channels, etc. And this internal unitized curtain wall system, in the spandrel panels, as you can see, instead of incorporating glass as an infill material, we have incorporated a sound-absorbing wooden slats, a sound-absorbing perforated panel with wooden slats within it into the spandrel panel to give you that natural finish in that particular building, but still incorporating a completely unitized curtain wall system, factory manufactured system that was delivered to the site. This is how the whole atrium looks. It's very grand, but also gives you a very natural feel. Sorry. The other project to talk about is the Wave Rock project, which is for Tishman Spire developers, which we did in Hyderabad. This was a flagship project for Tishman Spire. As you can see, is being in Hyderabad, etc., which is the granite capital of the country. The architects and the developers said, we didn't want a simple glass box again over here. We said, let's incorporate stone into the facades, into the project. However, we wanted to construct it like a commercial building. We don't want to wait for the whole building to be civil structure to be completed. Afterwards, you come with scaffolding on the outside. No. We want to do a completely unitized curtain wall system. So we used a unitized curtain wall system, but instead of incorporating glass into the unitized curtain wall panels, we incorporated stone as the infill material within the spandrels of the unitized panels. And some panels were all glass, some panels were all stone, some parts were part stone and part glass. So the detailing we had to capture, we had to work very closely with our partners, like Dow Corning, etc., with our stone supplier partners, so that we developed this particular unitized curtain wall system. And in this system, as you can see, is we have a combination of using clamps as well as structural silicon. So as you can see, is in the vertical mullion, joints, we incorporated structural silicon only. Whereas in the transom joints, at the stack joint, as you can see over here, as well as the typical box transom detail, we had a particular kerf detail where we had a kerf clamp that was incorporated into the particular stone, as well as a structural silicon as well. So that there was a mechanical fixing as well as a structural silicon bond as well. This project was completed more than a few years ago. We did the first phase, I think, in 2012, and then afterwards the second phase in 2015, and the third phase afterwards in 2017. And building is still standing today and looks beautiful. Has this completely natural feel of stone and glass. With the complete, doesn't just give you that all glass structure. Sorry. This is another project, My Home Grava, which has recently been done by us in the past year. These are 8 towers. It's a very high-end commercial campus. Recently been announced that Deloitte has taken over the first building, and they're moving in about a couple of months, 2-3 months. And as you can see, is this building has different shading elements. It's a completely unitized structure. 4.2 meter height panels by 1.2 meter width. At the terrace level, at the top floor level, we have 6.3 meter height panels. But very interesting system where we have different types of shading systems. So we have, as you can see over here, you have horizontal sunshade systems, which is around 400 millimeter deep aerofoil profiles, which are running horizontally. We also have vertical fins. So at the center detail, as you can see over here from the mullion, we have a vertical fin, which is about 500 millimeters in depth. We have used a double extrusion profile to sort of, to create that, to ensure we can procure the material locally. And then we have this is on the west elevation. On the other 3 elevations, we have this S-shaped fin. So it's like a C-type fin. So one fin, as you can see, is incorporated into onto the left mullion, which is the male mullion, and the other fin on the right mullion to create this C-band, vertical C-band. Now, what you can see amongst all these 3 different fin details, whether it's the horizontal fin detail, whether it is the vertical fin detail or the C-shaped fin detail, we have one bracketry system where the bracket is coming out from the mullion. And the most important part of that is, as you want to adjust the position of your horizontal fin at the project site, we have a particular very interesting over here. I mean, pointer I cannot figure out, but there is a particular, as you can see, there is a sliding insert which is inserted into the mullion. that particular insert can slide up and down along the length of the mullion, and at the location where you want to align your horizontal fin, you will just have to tighten the bolt over there with an Allen key, and it's a friction fit where it gets locked into position over there where it is. So then you don't have any misalignment in your horizontal fins. We also have an alignment pin through and through every horizontal fin, but we have a very adjustable mechanism to position your horizontal fin across the different mullions in the project. So this is how the typical assembly of the system worked. I'll just show that to you again. 1 second. Oops, this video is not playing. See it right from here. So this is how it is. This is the actual bracket we used over there, the actual extrusion. So we had a bracket that was installed onto the building. We had anchors that were fitted in there. There's tolerance for in and out adjustment over there. Then we had these particular panels, as you can see over here, where we installed these panels on the site. We had the horizontal sun shading elements, as you can see, the brackets were fitted. We had the fins that were installed onto the panel. And then these particular panels were then dropped into position. And then to level the panel up and down, we have an alignment bolt that we can accordingly tighten and loosen that bolt to allow the panel to move up and down based on to allow for that 3D movement. Besides that, we also had the other vertical fin element which I spoke about. So we had to the vertical fin, we fixed the horizontal fins to one of the vertical fins, as you can see like this, so that you had this particular vertical fin and horizontal fin interface detail like this. So on one side you had the vertical fin, and that was connected to the horizontal fins on the other side. So you had this panel mechanism where you had the vertical fin on one side and the horizontal fins connecting to it. And in the middle of that, we had an operable panel. And then you had the C-type fin as well, as I spoke about. So there is the L-shaped fin, either side L-shaped, to give you that C-shaped look to the element, the different type of shading elements, using the same bracketry system, using the same mullion, using the same fixings, was able to create different looks and feels to the building. So this is the project, how we have it installed. We have a few people like Raman and Ingit who actually visited the project site. But as you can see, we topped out the building, and just tower crane areas are currently being dismantled, and passenger hoist areas are being dismantled at the moment, and we're going to push through those areas where they are once that is dismantled. But we've done this in a span of 12 months. Is very interesting. As you can see, all the fins are aligned, different elements, vertical fins, horizontal fins. So what we did in this project is we did all the design and development in Revit, and we got all the drawings. Typically people would submit their shop drawings in 2D and then weight and system details. We designed everything as a 3D system in Revit. We uploaded the entire Revit model. So the architect gave us everything in LOD 150 or LOD 200. We submitted everything in LOD 400 and 450. We got our approvals on that basis, and post it was approved in Revit. We exported the entire Revit files and rebuilt them into Autodesk Inventor. And in Autodesk Inventor is where we then were automatically able to size our materials, size our glass sizes, size our panel codes, size our entire material takeoff from there. So this was, so going back this is how it was the first architectural model that we got. That was then converted into our LOD 450 model. Each panel is numbered, each glass location is numbered, each element is numbered, what element is what. And then from there, we were able to then export it into Inventor, and from Inventor, you were able to get your complete fabrication sizes, glass sizes, etc. directly from Inventor. So you just have to change the width and the height, and automatically it would get everything out based on that particular Inventor model that we had. So, it was basically a new methodology we followed. We used digitization and, different panel typologies, etc. Was for the first time we did this in this method, and we're following it in our future projects as well. This is how the Inventor model looks example, and how we exported it from there and how we took it forward. So I encourage everyone to embrace, using digital design, using digital technologies. We are doing that today in all our projects. We're doing, we have 2 projects currently going on in Gift City, completed one in 2000 and the first unitized project in the country, as I mentioned, and working on super high-rise projects, more than 10 towers of 250 meters in height. And this is the technologies that we use, and we're looking forward to working with all of you all in the near future. Thank you.
Thank you, Rohan. That was very insightful. So now let's welcome the firm in Ahmedabad, which is the pioneers of architect. They need no introduction. So let us call Vrutul from HCP. They are the firm who has designed the central vistas in which the parliament and the new buildings have been done. So let us give a warm round of applause for Mr. Vrutul Panchal. Thank you.
Hello, good afternoon everyone. I'm Vrutul Panchal. I am a senior architect and studio lead at CP Design Planning and Management. So basically we will be talking about evolution of facade system with shading device in India now. So it has a two component right now. Shading device that happened in post-independence India. So first, as we talk about the first facade design with shading device in post-independence India. So post-independence India, the kind of facade we had was quite in colonial architecture, which had a double shutter or shutters on double side of the facade. Let's say this wooden facade would act to cut the sunshade, and inside it had a glass shutter that used to just to get direct light inside. So that's how it happened. The lower shutters were mostly on outside, and inside it had the glass shutter that allowed light to get inside. Or in some case, the overhang facade happened on that was quite economical too at that time. And more on combination of both providing verandas or simple chhajas on the other side. But the kind of architecture India had was a quite detailing one, ordered one, it's kind of jali we had. And that reflected simply that those jali filtered the light inside through the veranda, through this jali, or some integrated jali work that happened in India back then. And eventually this jali filtered those sunlight inside, helping the Indian context to make inside room comfortable more. But the architecture shift that happened post-independence India, the rise in rapid development, there has to be a cost-efficient, quickly executable buildings, and integration of Indian architecture principle, the takeaway from the Indian building that we had, and response to contextual design language, and focus on fast and practical construction system. So here we had, Hasmukh Bhai were one of the pioneer architects in the post-independence India. So that's the Reserve Bank of India that we had in Ahmedabad. It was a simply deep shelf opening, isn't it, that allowed a generous shading to the building that make interior quite comfortable. Another example was a Dena Bank that has a narrow windows with a lot of solid facade in between. Again, a State Bank of India, that's again in Ahmedabad. So that was more of a climate of Ahmedabad that required such narrow facades. So the landmark example generally we take is the Newman Hall. It was a kind of facade system that we had in 60s or 70s or so. So if I explain you the floor plan of the building, it was a very simple building. Building use were basically hostel rooms and prayer halls and everything. It was a simply east-west oriented building, as you can see. Mark you. Okay, as you can see, it is very east-west oriented building. Now, some of the rooms are at north side, some of the rooms are at south side. So the more suffering were going to happen on the south side. So what Hasmukh Bhai simply did was add a layer, a thin fins on add a civil layer of facade over there. If we just zoom into that area and assess with the current technology, at that time we do not have the softwares like that could assess the sun shading happening in it. This simple fin and shelf allowed the room to shade it well throughout the day. So in a general principle, the way we assess is the 21st of June is the hottest day in the year, and get into the three time of the 9 a.m., 12 a.m. and 3 a.m. So 9 a.m. is not much a problem because 9 a.m. is the morning and the sun is not harsh at that time. The maximum harshness that you get is at 12 p.m. where a maximum amount of sunlight is going to enter. and it might heat up the room. But with this help of this shading device, there was a part of civil, no any engineering product, does its job very, very well. And it's an iconic building that's used for the Hasmui book as well. And that's the overall architecture happened in that time. So life was easy at that time, quite beautiful to do these things. But the contemporary facade design principle happened in today. That's where HCP is right now with the facade system with quite a modern technologies. In the early 20s, it was still straightforward to do facades. You simply provide deep set facades. But with prioritizing fast construction, people started investing most of the capital investment towards the facade rather than just building. So for a few of the example, there is the Aga Khai Canyon that we did in Hyderabad. It was again a very simple building. You simply provide a deep set facade with a clear glass, clear and wired glass. Again, that one we did in AES hostels, where a minimal windows were provided for the comfort of room with the DGU. And as the room size was small, this simply opening did its job. But here where the roller coaster ride starts, when you want a full glazed facade. That's a Wagh Bakri building that we did in 2006. So now this kind of facade really encouraged everyone to reduce energy consumption. You want large glass surface. Now you need green rating. Now with these factors, you need to do facade system quite carefully. So there are basically two components of facade system if we talk about. You need a glass and a shading device for a facade. And you will be able to do recess window, horizontal shelf, vertical fins, double skin facade or overhang. If I just take you through the first component, which is the glass. Now there are n number of glass available in market to do this green rating and enhance the performance of the building. You do SGU, DGU, TGU, reflective glass, high performance glass, glass break. There are n number of lists which would be available in market, more than that what I have listed. So we did one high performance glass in CCS and another we currently did in IFSCA. So now this tinting of glass has to be done quite carefully, and with the help of this shading device that allows ample of light enter inside the room, as well as you would be able to see through the building as well. So these are the key aspects that impacts building design. The glazing of the building, you need visual comfort, glare, artificial light, thermal comfort, energy efficiency, acoustic performance, green performance, etc. Now, if we just dissect this through the different verticals, let's say you need a visual transmission, you would be able to see through that window. And you had a U value that decides the energy efficiency, green certification, thermal comfort, and the other is solar heat gain coefficient that is decided by shading device and building orientation, and reflectivity. You get a mirror effect on both the side as you go for a high performance glass. So now this high performance glass, how it works basically. So you for visual transmission, decides the amount of daylight passing through the glass. The U value is decided on the rate of heat that pass through the thickness of glazing composition. And solar heat gain is the amount of radiation that is passing through that glass. And external and internal reflectivity is basically that the reflection happens on both you get a mirror effect inside and outside both. So if I just talk about the important aspect, which is SHGC value, it is decided upon the more heavy tinting it has, the more glass can be pushed towards the external facade. So it has a low heat absorption value, but very low visual transmission. It will be heavily tinted and it will generate quite a tinted effect. But when you provide a generous shading, when you offset those glass backside, you get generous shading, but you will also get that light tinting. It will basically help you to connect with the outside environment. It is very high visually transmission and low heat absorption. Now, the combination of these two, shading device and the tinting of glass, has to be done carefully. That's what we did in some of our building. So as you can see in this courtyard, it is a very huge 100 meters by 60 meters of courtyard. Now you're creating this huge courtyard and providing a glazing, you would be able to feel that courtyard. So that's what we did here. We covered all this long courtyard with a shading device, a metal canopy. It was a very well engineered canopy with a perforation that allowed light to enter inside, as well as we convinced our consultant that let's increase the transmittivity, let's increase the visual value that you will be able to see from inside to outside. In this image demonstrate that if you are in office space, again you can see outside that you can be able to feel that there is a tree, there is a nature outside the building. Again, same building. This is a conference hall. You would be able to see the tree outside the building. Similar thing we did in an iHub in Ahmedabad. So again, with the help of TDW, we were able to do this louver system around the building. Actually, again, it helped. This is a close look that it has a perforated operable louvers that help the interiors to get natural light and a visual transmission to outside as well. Again, the same building, you would be able to see that the natural light is simply coming in the open louver condition. And again, being a south facade, it is a quite comfortable and a filtered light coming through the facade in the interiors as well. Another example is this dining facility that we are doing for Ahmedabad Education Society. Now, dining facility being used throughout the day, it will require some ample of light getting inside, and it obviously functions on the daytime where we analyze 9 a.m., 12 a.m. and 3 p.m. Okay, so what we did, we went a bit forward. We provide a veranda with a GRC jali facade in it, so that the GRC jali could cut that sunlight, and we will be able to do less tinted glazing system inside. So obviously you do some pattern in it to bring up that filtered light happening and the pattern falling on the ground. So that's a good quality of natural light happening inside. Even though this is, you can see, even though you can see here, it is a huge 12 meter of span happening throughout. And again, the natural light is reaching up to that point. So that is a way this less tinted glass helps you to light room more without having artificial light. And again, you would be able to see through the dining facility from the outside. And again, we did one more fee shuffle back then. On the south facade, we simply provided, with the help of TDW, the louvered surface we had. Again, that helped the interior office space to get ample of sunlight. And again, with the closed louver, you get a filter light inside with a very visual comfort. The last building that I want to show is the IFSCA building. So again, respecting the context, you cannot provide those louvers here. You can see a lot of glass building in the context. Same, respecting that, bringing a modern architecture to the gift city. What we did simply was to provide a thin layer fins that were done with the solar analysis. Every fin was made in an angle, placed in an angle respecting the sun. So this is one of the video that we made, what's happening throughout the day with these fins. So you can see these fins are exactly doing its job, working with the angle, that it does not allow much of a light entering, allow filters light to enter inside the room. And that's so with the very light tinting. Yeah. Again, the same building, as you can see, this is on the north facade, where you have a straight fins happening. Again, the closer proof of that fins that helps the building perform better. Again, at a night, you will be, now there is a clear visual transmission happening inside to outside. So that's where this both the component works together. And with that, I would like to end this presentation. Thank you very much.
Thank you, Mr. Vrutul. It was amazing. So now let us call upon the stage the Superman of interlayer, Mr. Malvinder. So he's a go-to man when we have all technical queries regarding using interlayers and everything. So let us give a warm round of applause to Mr. Malvinder Singh from Kurare. Thank you.
Thank you, Shalin, for the nice introduction. So good afternoon, everyone. So my name is Malvinder from Kurare. I think the timer is not running right. Somebody needs to correct it. Okay. So my name is Malvinder from Kurare, and we manufacture the interlayers for lamination of glass. Okay. Yeah. So today I'm here to talk about some of the new developments that have taken for the structural interlayers for structural applications of laminated glass. So what you see over here, this is how we categorize our interlayers. On the left-hand side, we have the structural interlayers, and on the right-hand side, we have the non-structural interlayers. So the special focus is on the structural interlayers. So we have basically two types of structural interlayers. One is the family of ionoplast interlayers, and sentry glass comes under the ionoplast interlayer. And then we have another structural interlayer, which is Trocifoil Extra Stiff Pro, which is a stiff PVB. So what are structural applications? So we have some, these photographs. So these tell like what are the structural applications. So glass is not just a decorative element over here, but we have glass is a structural element where it is intended to support the live load coming from the people leaning against the glass railing, or it could be these kind of floorings, yeah. So I just came to know yesterday only a very unfortunate incident happened in this property some 5 years back. A man was smoking a cigarette, and he came for a wedding, and he was leaning against the glass railings, and the glasses collapsed, and he died. This incident happened 5 years back, and so if you don't choose the right type of the glass, then things can go very wrong. So here we have two structural interlayers, the sentry glass, which is the hero product in our portfolio. This is the best structural interlayer that you can have for structural applications because it retains its higher stiffness even in temperatures beyond 30 degrees centigrade. And then we have Extra Stiff Pro, which is recommended for interior applications. Yeah. Okay. So there is a reason why sentry glass is the big daddy of structural interlayers. So if you see this graph, it is comparing the Young's modulus of the different interlayers. So the yellow curve is for sentry glass is sitting on the top of this graph, which means it retains its high modulus in a big range of temperatures starting from 20 to 60 degrees. And then we have Extra Stiff Pro and the stiff PVB from other suppliers. And then the blue line is representing the PVB interlayer, which is highly compliant to the temperatures. So because of these reasons, sentry glass, just a second, yeah. So it's not just about the modulus number. So sentry glass has actually become the choice of the ADEX, which we call as architects, designers, engineers, and consultants for a reason. And it has been used in some of the mega projects all over the world. Just because of the simple reason I mentioned about these properties. So it has a big edge over the other structural interlayers which are available in the market. Yeah. And it's not only about the modulus number of the interlayer. So these 6 parameters listed over here, like the post-breakage strength, the design temperature, the edge stability number, and the performance in the salt spray test, which is for the open edge applications of laminated glass, and of course, suitability in open edge applications. So sentry glass is completely outperforming all other options available in the market. And then we conducted this post-breakage strength on the Extra Stiff Pro, which is I just mentioned about, and we made a comparison with other structural interlayers available in the market. So it's a 4-point bend test where you intentionally break the glass and put a load onto the glass surface. So you can see there's a clear difference between the performances of the two interlayers. Because even after low duration of 7.5 minutes, the glass laminate made with Extra Stiff Pro is still having a very minimal deflection compared to the glass laminate from the other suppliers. Then there's an interesting video here. Just think the video will not play. No, it's, see, there was a video. How do I go back?
Yeah.
Okay. So this was a comparison of the collapse load, where you intentionally break the glass and check its post-breakage performance by applying a point load, which means how robust or how strong it is to sustain the live loads which are being imposed by a person who is leaning against the glass. So clearly we saw that the collapse load in case of the Excessive Pro was almost 2 times than what it was for the other suppliers. Okay, then moving quickly to the next topic, which is related to how to specify our product, which is Century Glass. So Century Glass is the correct registered trade name that belongs exclusively to Kulare. We are the only suppliers of this product. And now there are at least 6 to 7 companies from China who are pushing they're trying to claim that it's a alternate of Century Glass, but it's not the case, and it's a completely fake product which they're trying to push, because it's not Century Glass and they're calling it as SGP. And we recommend to the architects and facade consultants present in this room to always check with us who are our certified glass processors. So we call them as QNL certified processors. So always work with them to ensure they are getting the right product which is specified by them. And most importantly, the end user who is paying for everything, they get what they have paid for. So if you don't use the right product in your project, these kind of instances can happen. Very high amount of haze has been observed in one of the projects which have been done with these fake Chinese products. And then another project which has made use of these glass fin applications. These are cracks in the interlayer. Nothing wrong with the glass, but these are cracks in the interlayer itself. Yeah. And then we conducted this impact test. So as glass railings, after this swing back test, glass is expected to stand erect, not collapse like this. And most importantly, the test was done at just 20 degrees centigrade temperature. Also, we made comparison of from 3 different suppliers for the yellowness index and the haze measurements. So these are quite hazy and yellow, as we have seen in the photographs, compared to our products. Also, we did the peel adhesion measurements from 2 different suppliers. We found that the adhesion is not really up to the mark, which was the cause of delaminations in the glass laminates that we have seen over here. So Century Glass is the preferred choice of the ADEX for a reason, because it has got the stringent certifications like the DIBT approval, the SECAL certification in France, and the Miami-Dade County approval for the hurricane market in the US, which are extremely difficult to get unless you have very strong checks on the quality and the durability of the product. This is a very important slide, which is actually a movie, short movie, which is important for the traceability of the product. So we are coming up with a mechanism to how to trace and
Now, Century Glass Interlayer can carry a digital fingerprint, a unique identifier that secures its history, quality, and journey. From our factory, your site, nothing is left to chance. At the core is Certiply, Kurare's blockchain-based tracking system, a decentralized tamper-proof solution that links data in chronological blocks. Every movement, every update, every hand it passes through is recorded and encrypted. Once created, the token becomes a living part of your project, moving across stakeholders in real time. It's not just traceable, it's visible, verifiable, and transferable at every stage. It gives you confidence in your material and proof for your clients. Discover how Certiply is shaping the future of laminated glass.
Yeah, so Certiply is going to be the next game changer for us, because this will really help the ADEX to really track, to ensure what they have specified is actually being used in the project. So I humbly request all the ADEX present, the architects, designers, and engineers to push the glass processors to adopt this Certiply mechanism for the traceability of the product. Yeah. Yeah. So I think this is my last slide. So I would just like to summarize what we have discussed here. So Sentry Glass is completely outperforming all the structural interlayers available in the market, and SGP is not really the right name for Sentry Glass. So kindly ensure that you are specifying Sentry Glass, not SGP. Then Extra Stiff Pro, we have seen some of the test programs being conducted, the post-breakage strength tests, those have been conducted, they clearly show it has a better performance due to its higher stiffness. And lastly, Sentry Glass now can be digitally traced and authenticated using the Certiply. So I'm available outside with my colleague Sumit. If you have any further questions, we are available to discuss. Thank you so much. Thank you for listening to me. Thank you.
Thank you, Malvinder. That was really, really very insightful thing. And guys, to experience Certifly on first hand, we have this system installed at our booth, IPH Glasses, so you can check how Certifly works. We can explain you in detail about it. So ladies and gentlemen, it's time for well-deserved break. So in the break, please visit our sponsors booth. So they have very good products, so you can have a look at the products. But make sure the time is just for 50 minutes. So whenever you go there, just visit the products, have a lunch, and just come back. So we will see you in exactly 50 minutes. So just make sure that you are back in 50 minutes. And we have a lot more things to come up post-lunch. So for that, I just want to say enjoy your lunch, enjoy the hospitality of Ahmedabad. Good afternoon. How's the energy? I don't think it's high. Let's do something. There are a lot of people waiting outside. Let's call them. What do you think? So let's do something which is full of energy. So what I want to do is, I just wanted to tap for 2 times and then clap. Okay? Like this. Everyone together. Still louder. Amazing. So now we have a lot of energy in the room. So now let us call Mr. Mitul Gajjar. So if you see the skyline of Ahmedabad, he's the man who has started the skyline of Ahmedabad. Technically, we can say that he's the fourth facade consultant of Ahmedabad. So he has done a lot of contribution in giving Ahmedabad the skyline what it is right now. Mitul sir, please welcome on the stage. Thank you so much.
I think after lunch, I think the crowd has to come. I think when you see the time, I have to start. Good afternoon, everyone. People knows me, but I'll say Mitul Gajjar. Started my career 1995 as a fabricator with the Shapurji. Now I'm practicing this facade industry as a consultant last 15 to 18 years. And I started this journey in Gujarat in 2012. Now it's almost 13 years to 14 years. Done projects in Gujarat almost more than 400. And proud to say that all the airports in Gujarat, I have done it so far. So the last airport was Dhole was pending. So we have currently designed that also. So today's topic, I think we have learned so many things. How the smart facade to be designed, what are the good materials available, what are the good practices of fabrications. So, but what the Ahmedabad needs, that we need to understand. How this high-rise facade, what the government of Ahmedabad thinking about it, how the gift city is looking about this. So what is the requirement of the facade on a high-rise? I think we'll just cover on this. So design consultation regulatory requirements in a high-rise tower in facade. So that's my subject. The first steps, the wind tunnel requirements. I think in the Gujarat, the city has made compulsory all the project which is more than 100 meter must go through a wind tunnel analysis. And there was a good practice they have started. And people thought about that, why we want tunnel is required and what is the benefit of that. And it is just kind of one small study and which is required for structure but not for the facade. But I'll just show you one example, what I did one project. And this was a project which is in Gift City, is completed. And when we did it, our analysis as per our standards, the wind pressure was just a 2 kPa. And that time we say this is the wind pressure, and we designed some concept drawings, and it has gone for wind tunnel report. And then what happens later on? When later on has come down, the analysis of the wind tunnel we applied on this building, and see what is change we offered. The blue which is there, which as per our design intent, which is as per I-75-3, the 2 kPa wind pressure. And when you see the red, which is captured from the wind tunnel report, analysis on structures and applied for facade, and then see the wind pressure is 2.75 kPa. So the entire building has a change of the wind pressure, and all the corners has changed. So what we did that the entire facade design, I cannot design the panel unit as gazing with the wind over 2.75 kPa because it's still a crime, because 70% of the building still is the 2 kPa. So what we did in practice, we have done the designing part with the 2 kPa. On the corners, we have made some inserts to take this kind of additional loads with extra pressure is there. So basically, that was it. So when you do once you have done this, so what is the next step? So there, the structures. So when you do the design, first you should know what the structure. When you do the facade design, now most of the people want the flat slabs with lesser beam, columns and everything. You go for PT slab. I have designed so many projects which I have found. The slab is only 300 or 250 or 150, and the tension cables are still ahead. So what's the problem? We can't make a fixed bracket. So I request that whenever you use such kind of building, you make sure that your consultant or engineering team should work out that how I'll do my facade fixity. So best practice is what we do it, that you put a casting channel during the construction, and or maybe you can do such kind of, you can see this. One second. This is not coming. Okay, this kind of adjustment done. We have made asked them to make the RCC upstand of 100 mm 150, so we can bracket. So what is the advantage of casting channel, which I will tell? The casting channel advantage and disadvantage I will tell. When you see the casting channel, you make sure your designs are intact from day one. You can't change later on. Because if it's, of course, you get a small arrangement of 25 mm, 30 mm, 50 mm, you can do it, but not you can change the entire facade. There, I have a grid line of 1.5, now I'm change the grid line to 1.2 mm. So this cannot be done. So make sure when you do a casting channel, because when it is to be implemented during the construction stage, we need a good facade engineer to implement this, along with the casting channel the supplier, as well as the team from the civil industry. So who's going to construction, we has to also require of this. So this is, and this when you do it, what is the benefit and what is the benefit? So when I'm doing this, I'm actually doing the floor finish and the transfer finish at 0, 0 level. I'm not making any upstands. For the developer, it becomes additional FSI of that additional which will take it to the end. So this is a benefit to the construction, the developers, that we don't have any upstands, which goes out of the FSI. And you see, when you do a 120-meter building one side, you consider that area of the facade which is covered in entire building, what is the area and what is the value of that. So the casting channel can be done. But here the disadvantage, you can't change later on. Your grades, marginal changes are okay, that's fine. So that is how it has been done. Second, when you do the design of building, make sure what we do. Okay, building aesthetic design is architect will do the best design. What do you want? A day lighting, how the indoor air quality and ventilation will be done. Thermal comfort, acoustic comfort, view and connection nature, green building design consultant, solar control, sustainable material, renewable energy. So when you design a building, make sure this point has been discussed in detail and you work out that yes, the first look of the building which have such, I have taken consideration of these points. If you are going for green building consultant or green building meet requirement certification, make sure that you get the inputs according to you make the design, and then you work on facade. So make sure what we did it, we done the analysis of the window, we taken care of in the structures. What we did it, we have done the structure we have made with the structure consultant and find out what the structure is available and what we are doing with the structures and how we are going to do fixity. We are given our all loads to the structure consultant, so he can design his structures and take the all consideration load in the building. Otherwise what happens, he doesn't design and we have a 7-meter canopy and then the loads cannot be transferred on the building. So this happens and because not done, discussed on very early stage. So, and second, these points if you consider in the building, I think you will be able to achieve your good building, which is meets the all requirements. Of course, building aesthetic is more important, the material, because now the building is, Ahmedabad is in high rise. Your building lifestyle is 50 years. Your material must be selected, which is a long term. You can't change, and because if you change, I have 10 years, I will start to replace the material which is bad and try to save some money now. It's not going to happen. 120-meter tall, 150-meter tall. Now I think latest is 165-meter tall building is coming up. And there is one more building is coming, which is from the Ahmedabad government, which is a 100-meter view gallery. So we are almost touching 200 meters. You can't change and repair things which is a 200-meter high building, which is occupied by the buildings. So daylight is, I just made the gist of this, that what is the visual comfort, fresh air comfort, well-being, quiet space you want, acoustic. Depends on the building, what you're doing. I'm talking about generic. It's required for commercial, residential, hotels, what you want to do it. According to that, we can design the buildings. Okay, 1 second, back. I think it's going skipping. Okay. This is 3 buildings which we have designed. I think 2 are completed almost. This is very long back. And if you see for the daylighting and control analysis, we have different material has been used. One of the project has been used as a glass box fin. It's not fins. It is not a laminated glass. It's basically glass box fins where the digital printing and daylighting is done. One building is just, I think HCP is done. They are already shown, which are done with the aluminum fins they have done. And the third, which is the Suresh Municipal Corporation, which we are doing the clay tile. And this building is designed, the highest clean pressure is there, is 3.6 given kPa, and proof load is 5.26 kPa, and which is, the system is just passed out that test, and now the panels are under installations. So this is how you can do the daylighting analysis, and you can do your shading devices, you can select, apart from that, I think we have seen in 142, they are in the tensile cloth, they have been used it, that also one of kind of material. You have to select the material which according to your aesthetics and everything. Now why on a high rise? So which product has to be selected? It is nothing but we say, I think all consultants sitting, they will say first preference will be they are unitized. Why unitized? Because it is prefabricated in controlled environment at factory, it has come to panels on site, installation is fast. I see the nowadays fabricators are on a race that I have installed 40 panels, I have panel 50 panels, I have 100 panels. They are in that race, and then says that we are the fastest. And the building time with the semi-unitizer control, which takes 1.5 years, and they do it in just 6 months, and the building is fast. That's a good practice which we should follow it. And I think most of the building in GIFT is almost, I think, unitized. And Ahmedabad also, it has been unitized. I have recently, and last 1 year, for the change, I have seen the shift in a residential building with unitized glazing. The entire building, residential, going with unitized glazing to have a better view from inside, and it's a good sign and it's a very positive sign, which happens in Mumbai, now it's happening in Ahmedabad, and you will see next 5 years, you will see those buildings which are residential with the maximum kind of glass facades, and with the unitized panels and everything. This is fast, the quality is the fast installation, reduce the site time, factory control protection, fewer installation errors, air and water tightness, because it's factory fitted, it just comes to hang and it just do the proper fixity. Air and water, structure step flexibility, thermal insulation, reduce acoustics. See, these are the benefits of the unitized glazing. It's not that I'm saying the semi-rise is also not good, but it takes some time. High rise you cannot do it because you can't have that kind of scaffolding, you can have that kind of gondolas to install, and the time frame goes beyond acceptance. So we should not consider that. Okay, I think it's going fast. Okay, one more thing is that now in Gujarat government and as GIFT City is compulsory asking for the third party test, which is test laboratory testing. Good sign again, because reason, when you do the building of 120 meter, 145 meter, 160 meter, and then you found there is a leakage or air leakage or water leakage, you go in a wrong direction and you can't repair those kind of buildings. So GIFT City is compulsory. I think Ahmedabad also is going in that direction to have such kind of test in compulsory. And they say before going for the installation, you such kind of do the third party laboratory test and do the mock-up test, do the rigorous parameters which has been identified by your consultant, and those parameters to be passed in third party laboratories, and then you put up outside. So that means the system is designed which is delivering this product, which can be a system design from the system supplier or B-scope design, which is also can be tested on a third party laboratory test. Now it is also doing in residential tower. I have seen so many buildings in Ahmedabad also going for windows testing, and they are going in that direction. Okay, yes, we should test the windows for air and water leakages, especially in Ahmedabad for air, because rain is hardly, I think, 10-15 days. But yes, in Bombay, of course, air and water is more important for us. But here, Ahmedabad stay, yes, we do it, but not that Pascal. That Bombay has a 450 Pascal. Here we do around 200 Pascal, 250 Pascal. But air and water is compulsory, and I think we should do it, and that's a good sign from the government that they are taking all the measures which is taken care of in a facade. It's a good sign. Like we do the structure audits, like we do MEP audits, we do it. Now the government, and I have seen the GIFT City is coming regularly to inspect your facade. That also again a good sign, which is very positive, that the government in self-monitoring your facade is going to be safe. They are doing fire or smoke test. They are doing fire, so those also, and they are recorded those things. Are good sign. So what we do is the air and water test, and these are the basic parameters you should go for testing, and that's a compulsory test which is required. So fire, I will not go because I have done so many fire models, given lectures. So I will just take the outline what is government wants and how governments are doing it. So it's a passive system. How will evacuate your people from the building? That your system required. You have a staircase or your pressurized staircase. You have you can have a refuge areas, and you have then you go to terrace. Those, and there are systems like sprinklers. You have then you have openable panels. Concept of openable panels is varies in all India level. People think that we can bring the people from the openables or top hung window or bottom hung window, because that bottom window will pressure. It's a concept. I think on all India, on a fire note, we are not still at one page what we require. So I think it's a debatable topic, and it's always very due to the fire engineer or fire authority of that state or that region, how it takes care of it. So it is again a big topic. I think we are every time we are talking this subject, but not to conclusion. And yes, we are doing best practices. So these are the guidelines, NBC 216 local fire authority. You can see this, their requirements are there. So what is saying about the openable or 2.5%, they are saying, somebody is saying every 10 meter is required. So there are guidelines from NBC. The NBC is only the guideline, but of course your NOC will come from your fire authority. So make sure that whenever you design your building, your fire authority have your letter with you that what he needs for the fire protection from the facade. So that you implement from day one in your drawings and implementation, because every region, every fire authority has requirements. In Mumbai or Bombay itself, in Mumbai region, it's a side hung openable window. And when I go to MIDC, it's a top hung windows. So it is a different way approach in Mumbai itself. So I think when you design your building, I think also one common document you should follow. You should get, whenever you are consultant board, please give him that this is my fire authority is given, and make sure that those things are implemented. Now everyone is talk about the testing and but knows about the fabricator, who's the heart of the building, and he is going to take all the pains, whatever the facade consultant design, what the architect design and everything. So we say that we need a good facade contractor. We have a lot of Mumbai, Ahmedabad, Surat, all over here. So make sure we should have a good facility of fabrication, and you should have a very good team. You should have a proper engineers on site. You should have a lot of latest machinery you should have, and then you should do a good fabrication first time right. What will happen if you do wrong things? What will happen? The glass breakage because you are not done your practice. window fixing properly, your glazing is not prefaced, you are not given a proper expansion joints, or you are not done it. You are not proper fixtures, so air and water comes. You are so done a testing in third-party laboratories, but your fabricator is not done a good work at site. The water will come and then we'll say, what is the problem? I done testing. So once you do that, the repair is not going to happen. You just apply silicone and then close. That's not the practice. We should follow the better fabrication, better installation. Thermal loss, of course, because air and HVAC, because air is almost transferred, the heat or the hot air is coming inside because of your opening joints are opening, and so that's where the water is coming. Poor aesthetic, of course, it looks very bad when you go to near to that building and you see that, yes, it's wrongly practiced or wrongly installed, and the building looks very bad. From far, it may be looking good. So, Bashir but Harbor, I think here good of the factories they are taking care of now, and the experience and now the vendors from Ahmedabad, Surat, Mumbai are here and they are taking care of it. So what is the facade? The design, engineering, procurement, fabrication, testing and logistics. They are they have to take care of this. When you transfer your material, how you going to transfer your design? Where the facade designer has done a good design, but then enhance those design, sit with the consultant, sit with the architect, what we can do better in this, how for you have some problem in installation, you have a problem in procurements, because now you know the problems are there. Sit with them, find out the solution, work on that, and start with prototype products, do the testing of those prototype products, then install at site, and then you move ahead, do the proper, you do the analysis, and you can do that. Of course, analysis, system engineering, value engineering, durability and everything is there, so that's I will not cover this. Okay, municipal has given the guidelines for the facade, 70 meter and above, how the facade to be taken care of. So all the norms has been given. What I spoke is already written over here. Then they say, okay, the fire smoke seal, your floor to floor, compartment to compartment ceiling also they are calling for it. It's not that you are doing floor to floor ceiling, they are also asking for do the compartment to compartment ceiling. So that also need to be taken care of. They are talking about MEP also, because the sprinklers and everything are there. You should not use the material which is a combustible material and is getting a fire. Use the product which is required. When you do high rise, use product which is have a life longer span. A stone or something, or good kind of aluminum cladding. You have a clay cladding, you have a lot of HPL cladding, we have a lot of product which has a longer span of life. You don't need to repeat after 20 years that I'm going to change this product. And then there is a lot of cost comes later part, and repair and removal and refixing is a very high cost. Nowadays the laborers are very expensive. You don't get kind of thing to do kind of people also. So I think this is guideline which is there, which is given by them. So cladding structures, glazing, what they want, smoke family, over parameter, fire stopping, of course. They are also requesting that whether you can automatic firing cameras connected with your openables and which can open. I think that's very early to say that, which is very expensive and they require a lot of maintenance in that. Apart from then, I request that whenever you do a 120 building, make sure you have your cleaning system on place, because that is a must for your building. We are trying to do with the Spider-Man, very wrong practice, we should not do that. It kills your all roofing material, and then water leakage starts, and then we blame that is wrongly fabricated. So please make sure that you have a proper system. It takes some cost, but it's for the betterment of the building, and facade will remain in good condition forever. So building also need, when you say I put up a glass, I don't need a maintenance. It's not like that. When you do a structures, you need to repaint it, you have to crack fillings, everything you can do. So when you do a facade also need a maintenance. You have proper cleaning, your openables are working in conditions. You have seen audited building, most of them are locked, either their hinges are bad, the friction, the handles are come out. Please make sure that all the openables are working. We have seen software industries, we have put the openables in all the facades and they put the screws and fix it up. Please don't allow them. It has for those on an emergency purpose or for the fresher purpose. You should keep it always in a working condition. So facade also need a maintenance. You should have proper maintenance team who they know how to bring to facade to be clean and to be maintained. So basically, I have covered the entire thing. The phase, it is required the entire structure from the design concept stage to the handover. You should, how you to follow the process, which are the process more important, how you should design your buildings, how you implement the facade into the building, and how you're going to maintain that building. So that is how, which I say, let us make a good facade, safe facade, beautiful facade, and make sure that the Gift City and Ahmedabad goes in right direction for the high-rise facade. Thank you very much.
Thank you, Mitul bhai. That was very insightful and very interesting. So we are obviously going to make more and more of high-rise towers. So for the next, we call our German partners, Suko. Mr. Harsharaj Shetty, please welcome. Please give a round of applause for Mr. Harsharaj Shetty.
Thank you. Thank you, Shalin, for the introduction. Good afternoon, everyone. Can I have the presentation? Yeah. Good afternoon, everyone, once again. So, today, on behalf of Shuko, I am here to present on a topic of innovative facade solutions. So, this is basically how Shuko is addressing the topic of designing future facades for India. So, to set the tone, to begin with what I'm going to explain today, the Indian facade industry has rapidly matured, with fabricators gaining strong capabilities in executing standard facade systems. There is a huge shift to engineered facades, and there is increased technical capability by the fabricators as well, by local fabricators as well. So what this is creating for system companies like Shuko is, there is a competitive pressure, because even the local fabricators, they are able to match the requirements what the industry is asking for. There is a huge push towards performance-driven envelopes, as Mitul sir already explained in his part. So with this, with the facade market growing at a high growth emerging market, the key takeaway from what we understand is the market is no longer satisfied with standard facade solutions. So presenting your standard off the catalog solution is not going to make the cut. So what is the challenge that as a company Shuko faces is local fabricators replicating standard systems, lower cost structures, because obviously because of localization and faster processing, ability to customize quickly, increasing engineering confidence, and then the price driven competition. So this is the challenge that we see today, and the response, what Shuko can provide or what system companies can do is work with complex geometries, look at bespoke within the system framework, have an integrated engineering approach towards project solutions, provide safe and tested performance, and then be sustainable, provide sustainable solutions for the long run in the industry. So today I'll be taking out through this 5 major responses that we as a system company look into. To begin with, I will start with the case study for complexity and how the architectural complexity is being addressed through our custom engineering process. So to start off, I want to begin with the project Panchal Vantage, which is a grade A IT commercial office based out of Pune. It's a landmark building, very beautiful. It has a total facade area of 46,000 square meter between the tower A and B, over a 12-acre space, and it's 79 meter tall with a 4.054 floor height requirement. And yeah, it's already under development. So what is the challenge that we had in this project? So this facade has a very complex facade with a glass geometry. The panel design involves inclined dummy mullions, so they form this triangles all throughout. And this diagonal mullions create a triangular pattern with the 4 panel combinations. And also to add it, there is a corner design, which again the triangular design continues. There is no break in the envelope design. And there are openable insert units, which are not our standard rectangular or squarish design. They are more trapezoidal and more linked to how they are placed in the triangular pattern. And then there are the staggered vertical joints. So every 2 floors, the panels get staggered between the floors, so to create that beautiful pattern. So how do we approach the design? So the design is basically built under the Shuko UCC unitized construction system with the female mullion, 7140 mm mullion. And then we have the Shuko AWS 58NI insert window and a custom cleat for the diagonal mullion, and the T-profile design for the staggered panel structure, which anyway I'll be taking up further. So this is just few images of the sections that was worked on. So as you can see here, Yeah, second. So this is basically the special cleats that was done to address the diagonal mullions. And then we have the corners as well, where it was for the continuation part with the cleats again. So how was the design basically? So for the T-profile design, we had a special T-profile done to maintain the staggered design. So this basically acts like a connection unit between the staggered panels. And along with that, the openable insert windows, which again, even though it is non-standard, the standard components, the standard fittings have been still maintained with the same operational features that is available in our standard catalog solutions. Along with this, it's not just the design, it's not just the system that's gone, it's a collaborative effort with between the Shuko custom engineering and our Shuko fabrication partners, which has eventually led to a landmark project. So this is basically what was the render, that was the start, and this is what we are at today. And I think as of today, we have the entire paneling is already completed for this project. So this is one of the case studies for the complexity thing. So now next I will move on to the second part, which is the bespoke. How do we understand, how do we go into the bespoke space without breaking our system's limitations? So this is a project for Taj Lucknow, a very small but a very unique project, because it's based out of Lucknow, India. It is a 3 basement level. It is around 38 meter tall, and it has a 3.5 foot. What was the complexity? The complexity was basically with the undulations of the facade. So they are like in a wavy design. So they have a requirement of load of 2.2 kPa, a watertight, very high water tightness requirement of 1000 pascals, and along with the seismic cracking. So what was the challenge here? The challenge was to maintain the different angles within the system limitations. So we had to adapt to multiple facade angles between 161, 167 and 174 degree. There was an open groove system requirement, and we had to also accommodate the overall seismic movement also with the horizontal part, and maintain the overall structural performance. So the design basically involved a custom engineer solution based out of our SFC 85, which involved creating multiple mullions for different angles. And then we had custom mullions and glass retention profiles to align with the angular requirement. And also there was the entire subframe system plus the AWS 58NI helped us to provide the openables that was required as part of the structure. So the challenge again was, the second part is the performance. So this one had an intensive performance test of around 14 parameters. It was a very rigorous testing requirement, majorly to understand prove the architectural integrity of the wave facade, ensure design construction is weather tight, maintain structural stability and system performance. Also then validate the system for long-term stress. So what is the design? So there was a special bracket design which we had to work on, majorly to address the seismic movement within the angular mullions as well. And then we had to implement a 3-barrier system, majorly to achieve the 1000 Pascal water tightness that was as part of the requirement. So we have successfully completed, and this is an ongoing project. I think this is what was the render, and this is what we are at currently. So I think it's almost done. The project is almost completed as well. So the third part would be the integration part. So this is more of an offering what Shuko can do along with a standard facade envelope. So today's facade envelope is not just glass and mullions. There are a lot of requirements that comes into a building. There is fenestration getting integrated. There is a requirement of smart and dynamic facades. There are hybrid materials that are coming into the facade envelope. And also there is a sustainability topic that is a major to look out in today's industry. So in fenestration, we already are providing insert units. We have top hung, we have parallel pop outs. We also are providing side hung openings based on the fire requirements that Mitul sir already explained as well. So that is also being given as part of our standard solutions. We do give glazed doors where you can have an utility door or have an entrance door as part of your facade, seamlessly integrated. And then there are sliding systems. So as of now, the industry is moving to such a way that there are residential projects where we see a lot of slider integrated into the facade. So in regions like Mumbai, where you can't provide a balcony, the sliders are always integrated with the facade to increase your FSI, provide integrated railing, and this is where we have solutions. And all this, can also go beyond this through our custom engineering. We do break sometimes from our standard solutions, we make some custom solutions as well. So on the smart and dynamic facade requirements, we provide for the Shuko ventilation systems, which is again integrated. Then we have Ventotherm, which is which helps you to ventilate the interior of the building even without opening the entire openable windows. And then we have Integral Master. So Integral Master is basically concealed blinds which you can add into your envelope. And then we have Shuko IOF, which is basically a data collection part where you can see the complete information of a system that has been put into your building. So this is completely digitally integrated, and through software and through the app, you can understand what is there, what has been added into your system, and what is the specification and so on. So moving on to hybrid materials, Shuko also has a offering for green facades where the entire the panels can be seamlessly integrated with your standard unitized panels along with drip irrigations. And then we have something of wood design, which is again a timber that can be added onto your facade profiles or your openables. And then we have Facade, which is a fabric facade, not your standard glass designs. So this is on the hybrid materials and the last part is sustainability. So there is Shuko Carbon Control, which is a 4-stage framework which helps in reducing overall carbon that goes into a building, right from the design until the construction phase as well as the demolition phase. Shuko AOC timber helps you to integrate with wood as well as aluminium, make it as a combination. And then there is something called Shuko Minimal Wall, which works on the concept of using glass as part of your overall structural deflection requirements. It's a special innovation that has been brought, and lately we have also tested this, and we are able to achieve a reduction of overall 40% in the aluminium that we use in our facades because of the minimal wall concepts. And then the BIPV, which helps you to integrate BIPV cells into your facade solutions. So that was on the integration part. Next would be the safety. So as we move on for high-rise buildings, there is a requirement where there are windows that are going on, top-hung windows on very high-rise buildings, and there is always a dynamic wind having different vortex. And this causes a stress on the window, and there are chances that this can, the hinges or the friction stays can get damaged or can fall off because of the swaying. And this may lead to, anyway, very bad situations down the line. So how does Shuko address this? Shuko has brought in something called an engagement catch, which prevents uncontrolled opening and closing. Basically, what it does is when the window slams it, it holds it in position and it doesn't let it to move in and out of under a wind load condition. So this has been tested completely. It is this is basically an understanding of how the engagement catch is. So the bottom part sits on the outer frame, and this goes onto the vent frame. And this is a spring attachment which helps you in locking when it slams onto the outer frame. So along with that, we have also introduced safety catch, which is a redundant safety feature, which in case the window completely fails, the hinges completely fail. So this helps to hold the window even when it has completely failed onto the building and doesn't let it to fall over into the ground. So this has been intensively tested. So how do we ensure the testing for an article which we don't have a protocol or a standard? So all the real world scenarios, which is again window slamming or the window swinging or just hanging on the safety catch, has been converted into a loading scenario, which is again impact load, dynamic wind load, and sustained load. And how are we addressing these two tests? One, the impact load is tested through drop test and pressure blast open. The dynamic wind testing helps you to understand how the window or the safety articles are going to behave under dynamic winds. And then there is prolonged hanging. Basically, you let the window hang on its safety catch to understand its effects. So there are some, so this is basically how the tensile testing of the rope is done. And then we have some videos of the drop test. This is to understand how the safety catch is going to work. So we just pull it out so that it hangs out, basically simulating when it fails. And there is a pressure blast open test, which again simulates under high wind loads. So you can still see that the window is still intact with the outer frame. And then once it is completely out of the window and out of the building, how does it continue under dynamic wind load? Because it can be that there will be can take some days for the repair to happen, and how does it survive those conditions? Okay, so and the last part, since I'm almost out of time, so sustainability. So sustainability is a topic which Shuko has been continuously talking about in the market, because this is important for us. As we all know, there is an increased aluminum consumption in the industry, throughout the industry, and this is going on. It is going on with a 5 to 10% year-on increase. How do we make sure that even with the increased aluminum consumption, how can we be more sustainable, since we are more into aluminum systems, right? So India's part to sustainable construction is India has committed to achieving net zero greenhouse gas emissions by the year 2070. So this is how Shuko India is aligning to it. So there is a rapid growth of high-rise commercials and premium projects requiring modern sustainable envelopes. So green building certifications have been introduced to address this. There is a circular economy alignment that is also required between recycled aluminum and renewable energy manufacturing. So considering this as the base, Shuko has introduced something called as the green aluminum, which the idea is what we are what the carbon dioxide emission is, what we are at now, we want to see a complete 90% reduction by 2040. So this is basically what we want to achieve. And towards this, we have introduced our low carbon aluminum profiles. So there is a renewable, they are based on renewable energy waste production. We have low carbon, and we also have ultra low carbon, which is basically from, which we are already selling as a standard system in Europe. And we have got this EPD verified, and yeah, basically it helps you to reduce. Along with the sustainable materials and overall material optimization through minimal wall or through our custom engineering, we are able to reduce the carbon that is being put into the building. This majorly helps you to get through your LEED, IGBC and Graha ratings. One of the biggest achievements towards this would be the big milestone for India is we have been able to get the first low carbon project. We have been able to convert a project where there was around 75,000, just 1 second. Yeah, the project would consume approximately 75,000 kg of aluminium. By choosing this, we are able to reduce the overall carbon footprint to 6 kg of carbon dioxide emission from 20 to 24 carbon dioxide emission. And this gives an overall reduction of up to 75% embodied carbon in the building. So with its first project using carbon dioxide, we want to take a step closer to leaving it better. And with this, I just want to finish my presentation for today. Just closing with the saying that we are at Shuko, we drive towards building sustainable facades through combining architecture with performance and sustainable solutions. Thank you for your time.
Harsharaj, that was actually a very good speech. And the best part about it is that you are moving towards sustainable. So aligning with our country's goal of net zero by 2030. So it's an amazing initiative. We all should appreciate what you are doing. So for the next speaker is Reza Kabul sir. He's a man, a legend himself. So the current building what you are sitting in right now is already designed by him. So he's doing amazing projects. He's also doing one Hayat, if I'm not wrong, in a gift city. And he has done some marvelous architecture. So let's not waste time and give it up for Reza Kabul, sir.
So, good afternoon. I'm going to run you through 4 decades of my practice and 4 decades of what we've gone through and how the facades have evolved. So, we just go ahead. So, this is the Broad Museum, Los Angeles, California. The facade is not independent layer. It is the result of building's inner logic. So it's not that, you do a building and you just do the facade outside to, cover it up or something. But it's something that it is integrated. It's a story that is there. It starts with the inside, comes outside, or it's the outside and it goes vice versa. So, and the facade is very important because you look at the facade. First thing when you see the building is the facade that you're talking about. So that's very important. Then facade design thinking, a 4-decade evolution. So first what we started was with, in 1980s, we had postmodern expressions. So they were all cornices and, different type of elements that were brought from the classical and built along with the facade. Then we come to the 1990s where you have high-tech glass. 2000, we have digital revolution, where we have something on the facade which is, either integrated in the glass or you have digital printing and various other forms of facade. And lastly, we have now the 2010 onwards, we've got into smart and sustainable, where the buildings are getting into green buildings and it's changing the whole skyline. So in 1980 to 1990, we have the postmodern expression, as I said. And here we have the classical ornamentations, which is there, and that is, along with the glass embodied, and it's got a symbolic context to the design. So, and then we use a lot of these precast concrete cladding, a lot of granite with or any stone along with the glass. Then we have, the other in 1900s to 2000, where structural glazing with elements, they started showing the elements outside. What was there, your services and everything was exposed. That's the Lloyd's building in 1986 in London, which has all its services and everything exposed. And then we come to the next era, that is the 2000s to 2009, where you have all BIM coming into it. So you have a lot of integrated, tools that we got in, we started using. So we could do all parametric forms and diagrid. That's the Gherkin in London, which has got the diagrid and the parametric forms. And now we got into 2010 to 2020, where we have the double skins, we have the greens, we have large overhangs, so that, we get good sun shading and a lot of greens on the building. So that's the Park Royal collection in Singapore. And lastly, what we have is the 2020s, this is the smart facades with biophilic design and net zero ambitions. So we've evolved right from simple facades to, facades which are technologically very friendly, and they have a lot of, so they relate to the environment, and they talk to this thing. So like we have the AI controlled louvers, the living walls, then your mass timber cladding, adapted scenes, which, with the various forms of light, the heat, it opens, closes, recyclable cladding, embodied carbon focus. So we've been through the entire 4 decades with various these things. So Then we come to the main drivers that are there, forces reshaping facade. So what happened is suddenly we started realizing, we started building too much, and we started realizing that we were, not very friendly. We were doing a lot of, buildings which were not, we were, harming the environment, and the climate crisis came in. So then we come to the computational power, that is your exponential growth, and computer cladded, so we start, because we got a lot of technologies, we could start going into various modernization and improvisation of the facades. Then we come to your, the material science advances. So we got the new materials like aerogels and various other films where we can, just, it's expanded, and the whole facade is created. Or the occupants well-being research that is there. So that is with the green biphilic architecture. And of course, the last one is digital fabrication. So when you look at buildings, in the initial stages, we had facade typologies in the last 4 decades. That was, single glass, single skin. They used to attract a lot of heat, and it was not very friendly, but that was the only thing that we had. We didn't have too much of technology at that time. And then came the curtain walls, which we started doing a lot of curtain walls on the facade. But again, in India, we started copying them, but they started using annealed glass. They were not ready to spend. The clients were not ready to spend, so it was becoming a little challenge till there were accidents. And then later on, what happened is they started actually adapting to the, double glazed and various other forms of this thing. Then we come to your double skin. So in the 2000s, we started doing double skin buildings, and then adaptive skins. So these were the various the things that we came in. Now, when you're selecting a facade as an architect, what are the things you have to look at basically is climatic responsive. It should be climatic responsive. The design intent should be proper. Budget and life cycle cost. This is very important because most of our builders in the country or the developers are very price conscious, and it's very sensitive. And of course, performance. So performance, the glass has to perform well, and that's very important as well. So if you look at the various these things, like in 1998, we got the AutoCAD, and when we got the AutoCAD, we started, getting into more precision, more precise these things. And in 1995, we got 3D. That is, we got the rhinoceros, we got 3D enabled. So we started doing more complex forms. And when we got parametrics in 2000, so we started going in for more complex and more technology-driven facades. With BIM integration in 2007, we started, various other forms and structures that was there. We could adapt it, we could this thing. And in 2013, we had the energy plus energy simulations and various forms. So we could actually check how much the building was, using up energy and how much we were saving energy. And now, of course, AI and digital twin learning. So what we can do with that. Then we have today, the future. What the future, the next decade holds for is self-healing materials. So concrete with embedded bacteria that precipitates calcite to fill cracks autonomously, extending facade life to 100 plus years. So that's what the next thing is. And of course, the algae bioreactor skins that is there, which is coming in, and it's already being used. Printed robotic facades. And Then we have the photovoltaic facades, AI governed facade, how much light should be got into the building, how much should we think to optimize the energy, and of course demountable facades. So this was the entire journey that we've been through, and what are the parameters and the various these things like from the 4 decades that we have gone through. So these are some of the projects that we are doing and we have done, and I just want to run you through that. So this is a project we are doing in the Gift City, and it's a fintech hub, and this is the facade is the fintech hub facade is a digital materiality. So by using modular pixelated skin and shifting architectural volumes, a dynamic interplay of solid and void, the integrated sky gardens and deep recesses not only define its iconic silhouette, but also prioritize occupant well-being and climate responsiveness. So this building is it's for the fintech, it's for the Gift City, and here we have various users in this building. So we have this as the main area where we have the auditoriums and the other common amenities. These are startups, these are accelerators, and that's the gift office that's coming up over there. And what we did is we tried and gave each of them their individual areas and their recesses so that we get the maximum sun shading. And Gujarat being very, it goes up to 48, 50, so we try to keep the sun out. And the other thing is that we are creating green pockets, green terraces on the intermediate floors to cut off the heat in the building. This is another building that we are doing in the Gift City, and it's a multi-level car parking building where we have 5 basements in the 5 basements for multi-level car parking for the city. Then we have retail, and then we have a mesh, perforated mesh where we have the parking for the towers on the top. And we've got 2 towers. We have a central, the globe that is there. So this globe is a restaurant, and it's got an observatory as well. So the construction of this is a little challenging. We have 2 buildings which are separate, and they both move independently. And because they're moving independently, we have the globe which is in the center, and one side is fixed to the main structure, the other side is a movable joint. And the whole globe is going to be constructed downstairs. It's a steel fabricated globe. So we are constructing the whole thing downstairs, and then it's going to be lifted and put into place. So it's a very challenging project, but I'm sure it's going to be a talk. Sorry. This is another building we are doing in the Gift, and again, we are following the same principles of, deep overhangs, lot of greens on the building, and vertical fins, trying to cut off the heat from the, reaching the offices. This is a project we are doing in Amritsar, and it's a hotel, it's a Pullman. And here we have, again, it's a full glass facade. Amritsar, again, is in the summer, it really gets hot. So we have the vertical fins which are cutting the light. And on the top, we have a restaurant that is in the glass box, which is projected outside. And there's a pool which is there. So it's a very interesting project as well. Again, Gift City, we are doing this tower, which is a Hyatt Regency and commercial with retail and public areas downstairs. So here we have 2 buildings which are separate, and then they're connected on the top. Here we are using high performance glass, and the building design is a very interesting design with the pool right in the center over here. This is something, which is not something to do with glass, nothing to do with the facades that we are talking. This is a samadhi, and this is for the Sadhu Vaswani mission in Pune. So here what we had is, there was one saint was there, he's called as Bade Dadaji Sadhu Vaswani, and then the smaller one, he passed away a few years ago, and they wanted to combine both the samadhis and give it a character so that it becomes one. So we came up with this design. We had a little story to it, because they believe in lotus, and there are some principles that they have: equality, unity, peace, love, and the whole thing becomes oneness. So we took that concept and we made the whole structure to become like a oneness, and we have the lotus on the top. So that's how it is. And the entire structure is 19 meters tall and 20 meters in diameter. So that's how this was the existing one, and then we proposed this, and that's the structure. So I'd like to go more into detail how we did this, because we didn't want it to be too thick. So we wanted it very thin, and we wanted it to look, slim. So we came up with a steel structure. But when we were doing steel structure, we thought, there'll be a lifespan to the steel. So the trustees and everybody decided that let us go in for a stainless steel. So the structure is a total stainless steel structure, and it is cladded with Makrana. We went and sourced out all the Makrana marble, and we started the work. I'll show you pictures of this thing as well. But when we came, it was a challenge, because the design is a parametric design, and it goes in 4 directions, 5 directions at times. So fixing the marble over here was a big challenge, because on the curve, how do you fix the marble? So we did steel members. That's the design on the roof. So what we did is, the external part is marble, and doing the roof part over here, the brown color you see, that we did it in Korean, because fixing marble on the roof in the reverse side would have been a challenge. It was a challenge, so we came and we did Korean. And so that's the inner marble, and that's Korean. So this happened because, we had all the parametrics, we had all the grasshopper, we had the BIM, and all these, technologies that we could use to implement this design. So we actually, if you see, each marble is a different size and in a different curve and a different shape. So you can see how it is. And then we went and did each of these marble sizes and how we would fix it. So we have, I'll go to the next slide, you can see it better maybe, where we have, these are your main stainless steel members, and these are plates, stainless steel plates. Now fixing the marble on the stainless steel, so we had to work out, we did some detailing for it, and we have some angles, cleats coming out, and the marble, there's a male-female joint kind of created, and we did this. So if you see here, this is how it is. This is the stainless steel members that we have, and these are the stainless steel plates, and you can see these are small cleats which get into the marble, so we've got slot. Now these marbles, if you see, all of them have got different shapes. So these are all 75 mm marble, and that has been taken and shaped out. So getting these marble was such a challenge because, it is Makrana, white, and getting that was a big challenge. All these members, if you see, they are solid, and these are curved in these fashions, and it goes all the way. I think our friend helped us doing the facade, And so this is now ongoing. Even you see the curves that we have. So we have some rods and metal fixing that we managed to do the entire fixing. So it's now the structure is almost there, and we are still in the finishing process, and the lighting and everything is going on. So we've done a lot of high-rises and That's myself. I started my practice in 1988. I graduated from MS University of Baroda, and we are headquartered in Mumbai. We have an office in Ahmedabad and Pune, and of course our overseas office is in San Francisco. We've done number of buildings, towers, and we are doing many of them still. So what we do is we do architecture, we do high-rises, we do interior spaces and master plannings. So this is always what I say, a building is remembered by its facade because it's where the structure becomes identity and engineering becomes art. Thank you.
So that was really compelling and very insightful. We are very lucky to have this kind of us, and also we are very lucky to work on a couple of projects of Sir. So without wasting our time, let me introduce to our next panelist, moderator of the panelist, Mr. Bhrugu Kangadia. He's an architect with I&I Design Studios. So basically, he has done some amazing buildings. If you look at the Gift City, they have given some amazing towers like IPL Potash, Shivalik Curve, Shiv Twin Tower. So his design is very minimalistic, but very compelling. So when you look at his designs, they are very much aesthetically integrated whole roof. And also the design and the skin of the building is done in a way that it is a spatial experience. And the facade of the building is integrated as a part of the building. So without wasting any time, let us give a huge round of applause for Mr. Bhrugu.
Good afternoon all. So let's begin with this panel discussion. I would like to get you Manoj Joshi. He's executive partner with HPA Architects.
Thank you.
Bhaumik Patel, he's an architect, founder of, principal of Bhaumik Patel Architects. Upendra Vankar, Aluvision Facades, he's a facade consultant. Chirayu Ojha. So today's panel discussion is about like influence of digital tools, modeling, and the future of the industry. So let us start with how this industry has shaped. So we have high-rises in industry started in late 1880s. So those buildings were sheer wall buildings and facades were just the opening and they were integrated with the structure itself. So in late 1900, like we started to see the digital revolution with 2D CAD, later on with 3D softwares. And that is how the industry has proceeded. And today with advanced computing, AI, that is an endless possibility. So we intend to cover the role of digital technologies and influence in our future of design. So Manoj, can you please start with the brief of how the industry has moved on?
Sure, thank you, Bhrugu. Am I audible? Am I audible? Yeah, okay. Yeah. So let me start with that whatever I'm going to say is from the perspective of a designer, because in the room we have a lot of people who are more knowledgeable and technically more skilled in terms of facade designing. So whatever I'll say is based on my experiences as a designer, as an architect. So if we talk about historical examples, let me cite two major examples which come to my mind immediately. One is Taj Mahal in India. Everybody has seen, I think, Taj Mahal, right? So initially what happened, what was used to happen is the people used to depend a lot on material which was available around in vicinity, or maybe the craftsmanship which is prevailing at that particular time, and also the understanding of local climate. So if you see a Taj Mahal, it is a very monumental structure. So first thing which was taken care of was the scale. Second thing is which was taken care of is the modulation of surfaces. And third part is normally what we see is the facade when we design any building or a facade. We always think about the surfaces and what we are supposed to do. But if you have carefully observed Taj Mahal, then if you see there are 4 minarets which are at the corner of the Taj Mahal also. In fact, these 4 minarets normally enhances that visual identity of that structure which is in the center of a Taj Mahal. So that is basically comes with the perception of an individual person or an artist maybe. Second example comes to my mind is Adalat Stepwell, which doesn't have any facade, to be honest with you, right? If you have been to Adalat Stepwell, we go below the ground and there are no facades. Basically, building is below the ground. So what happens? There are internal facades. So people normally used to rely on experiences rather than the facade, which actually immediately comes to our mind, right? And India has a tendency of building with shades because we are very we have a lot of sun at our disposal, right? So we always used to build with shade. Even if you see Indian streets, we are dealing with shadows basically. While the West builds with the sun, they want sun to come in basically. So basically the facade engineering which we are practicing, the concept has come from the Western countries. So that is the difference right now I see from the prehistoric time and the recent time.
So earlier, like it was more on craftsmanship, hands-on designing, detailing. With the change of the hour, the need of buildings going vertical, the penetration of light for the users and users who are inside, and with the digitalization, so the shift has happened, and the industries have progressed.
So, what Mr. Joshi has said, earlier we are having that craftsmanship qualities, and nowadays many of my industry friends will understand we are struggling with the skilled manpower sets, and where the digital tools are really helping us in predictive decision making instead of experience based. Certainly experience is winning over the digital tool in terms of digital tools are giving us predictive decision making, enabling us to take a decision which are related to the final outcome. So I'm saying it is helping, and our industry in terms of digitization, it is helping us a lot.
If I'll add on, I totally agree what he said. Initially, it was purely craftsman, right? An artist or a designer put their soul to execute, to make the drawings. But now, when we have a lot of softwares and the AI and other AutoCADs and many softwares like Beam and all, so the things are getting a bit easier for us. But same time, it is being a designer, it is our responsibility that we know how we use that, but same time we also answer that why should we use the software? Are we doing justice by using those software or not? That individual designer's responsibility. That's what I think. And by using those softwares and all in a correct manner, keeping in mind the culture and the regional aspect that help to improvise and embrace our culture. That's what I think.
Yeah, there's a tactical shift way the buildings and the facade was seen earlier and presently, like with all the computer-aided designs, optimization, and all those things. Like we see a big shift in way industry is moving. Stuart, what do you see like how the computer-aided tools are?
Digitalization area, how we were kind of, drawing. Yeah, just pre-digitalization area, we were like, I still remember when we were in Incept, we were just drawing everything and making scale models. And now the shift has been, completely towards using digital tools. Like we have been using it since last 20 years. And that's not just the 2D aspect of it. Even we have been using BIM since 20 years, and India is now kind of becoming an emerging market in embracing these technologies. And this has been there in being utilized, like Reza Kabul said, that in global markets we have been seeing that, and India is now, kind of embracing it more. In terms of, like what he said, there used to be some character to the buildings when people were designing with sketches and drawing through hands. And sometimes it does feel that when we are using just skin for facades, it kind of gets monotonous to a certain extent. But like there are some pretty good examples where using parametric designs and creativity, you can also come up with some fantastic facades that was not possible, or I would say it would take a fortune of time to execute them, even during the design process. Like we worked with Atkins on the Harry Potter project, and I cannot imagine doing that without using digital tools, and because everything is crooked, nothing is straight. So I think it just helps you mitigate risks and also implement it in a very professional way.
So it gives accuracy and control.
Yes,
Can
absolutely.
I add something into this particular point? Am I audible, right? So what happened is initially we didn't have those softwares or maybe very digital tools where we can explore certain geometries, which is now very much possible to explore. Initially, we only used set square, parallels, maybe max flexi curves. So you don't see many permutation combinations of geometries. Even if you find or see any historical buildings, they will have very pure geometrical buildings rather than very complex geometry, which is emerging out of nowadays digital tools. So I had a very good teacher, like you also studied in SEPT. We had a very good teacher, Mr. K.V. Jain. I will give you a very peculiar example. We had a history as a subject, and we were supposed to give a final exam, and my friend and my colleague Hiren, he answered all the whole question paper in sketches, and we wrote down certain issues, and he got full marks because he understood the proportions and the sense of the elements of the historical buildings, rather than only talking about what are the principles. And principles never change, only the applications or the way of applications change.
I think it's the medium that changed.
Yes, absolutely.
Right? The feel which we used to have while drafting
so
and
what
sketching.
I say is that intimacy is missing, and nowadays what is happening is we are entering into a time of fragmentation. Basically, if you see, I design, I leave it to MEP people to take care of MEP services. Then there are facade engineers, designers, my friends, all in the room. So each aspects of the building is fragmented now. So because of we have to understand the practicality of the building. So that's why this specialization has come in, like doctors they have. So nowadays it is happening that finally all the data or the concepts are brought together to get a practical solution to a particular building, because the scale of building is also changing nowadays.
So I'd like to step a bit back, like in early 2000s or 90s, like where stick glazing was like prominent, and when the building is done, like you have to measure it and get the drawings digitals and like, for the panels and for the things to be in place to design. And there was always an hit and miss kind of an approach, like due to inaccuracy of the transformation, what is done on site. So Upendra might have like experienced more of such issues in like past, and what is happening at present with the change in technology shift.
Yeah, I remember, as you had touched the right point, earlier when we are doing semi-unitized kind of a structure and when the digital tools are not available to that extent, many times it is, a complex geometries has been resolved with template, making the framework at site, put a wooden template, take that size, send it to glass processor, he will manufacture. I remember I had done one very fantastic job in Jaipur in similar manner, but certainly it took a long time for each glass to be, template to be cut, holes for the spiders to be fixed, and then sent to processor and coming back to us. And changing from that, we had done few interesting projects where, if you see, it is at my personal capacity when I was working with some other company, ATC Tower, in Mumbai ATC Tower. The whole glasses for that project has been worked out from the 3D model. Not a single glass is a template, and each glass is different. So that is one of the iconic structure we are seeing and still standing good from last 12 years nearly now. Another project we had done, which is in ITC Colombo, we had helped L&T for the Sky Bridge, which is 56 meters long. In this, we had resolved the geometry because earlier when it came to us, the geometry, each glass, it's a curve inside and curve in plan. So each glass is different with a fraction of, 2 to 3 mm tolerances. With digital tools and softwares, we had standardized each row so that in future any breakage happens, it helps. So that is really a time saver because you don't depend on templates. You are ordering 100% glass sizes as per model, and that kind of facilities are available. And this kind of integrations are happening at design, fabrication, and installation. What Rohan has shown on his My Home project, where from Rivet they had taken the input, it has been taken into Inventor, and from Inventor they had taken the fabrication outputs and glass orders, MTOs has been worked out. So nowadays we can visualize whatever architecturally complex geometry, the solutions are there which are simplified, repetitive, and can be achievable.
So what I understand with the change in the softwares and change in advancement in engineering,
right.
So it's all about optimization. So we are able to minimize the wastage of materials, especially when aluminum is going, cost is going higher and higher. Optimization in terms of like facade costing, optimization in terms of how to engineer the facade in terms of heat gain. That is all like being handled very dynamically in this present context.
Right.
There are different softwares, right from the modeling softwares like we can use Revit and integrate our all services in one. For advanced computational, we have like Rhino and the various plugins. So, Chirayu, like any particular experience and how like it has been?
I would just like to add before I speak on that, what he's kind of trying to say is that eventually it is more about reduced change orders during construction before everything goes for construction. Previously, without using these BIM tools or any other digital tools that we are using right now beyond, it was, change orders were a norm, and right now change orders are becoming exceptions. So that's where it's helping us a lot, and the owners a lot, that they're mitigating risk in construction a lot. In terms of optimizations, yes, I agree. The overall amount of time that it can take to generate these designs to a more practical way, like from concept to kind of a prototype, it can go really fast. If we are using tools like, like you said, mentioned Revit, yes, use Revit in conjunction with Dynamo, so it adds a lot of power to your automation tools that it can do with Revit. You can use Rhino and Grasshopper together to kind of, again, create fantastic facade options. So just to give you some examples, we had couple of clients who had certain requirements. We did a hospital for Children's Hospital, and in Australia, there they had the client had a requirement that they wanted the facade to be very colorful, and they wanted that to be very random. The colors had to be very random. The metal panels had to be very randomly colored. So that's where we kind of used these coding tools, where we used Dynamo in conjunction with Revit, and using custom seed or slider, you were able to kind of, just slide it and see the change happening in real time. And the client was able to play with it, and then they were kind of, they said, okay, let's freeze it with this design. So yes, it's definitely helping in creating and visualizing things in a much time-saving way.
So all these tools are there to help us integrate in totality the entire mechanism, the engineering of the building. And all those things helps us to observe and analyze in real time.
Yes.
So not only engineering aspects of it, as well as the visual aspects are like dynamic. With every change, the parameters change and the aesthetic of the buildings change. The softwares are gone this advanced. But what is the present scenario in our industry, and with all these tools at our disposal, we being consultants in different fields, like architects are here, and we are facade consultant, you are a computational tech guy. So what is the best alignment, and where we see, like, there is a disconnect in general in the industry, and how it can be mitigated for the betterment of the future of our industry?
So, based on our experience of consultancy, certainly on large project, the digital integrations are happening, as we said, BIM we are using, Revit we are using, and it's more, I'm seeing more in terms of coordination. I think we need to step ahead on many projects and get into design performance driven and execution level of details to be taken for these digital tools, which is possibility. However, we are seeing challenge of aligning people and using this software in the right manner. That is the one thing which we are seeing as a lacking, and many of projects get suffer because of this kind of capabilities not available with all, the capacity of fabricator. There are few fabricators who are into this, and rest are not able to involve into this process because of lack of skill set or lack of people who can handle this kind of challenges. So that is one area I'm seeing, but I'm seeing on other side there is a huge potential, and we can speed up the activity in terms of what we had discussed about the standardization, optimization, performance, all that aspect.
I think the collaboration between the facade consultant, collaboration between the designers, the the executors who execute the buildings. So the awareness and educating more to the people, that I think help to fasten the process and to understand and give the quality works, which again help us and the users also in a better way.
What I say is like Reza sir said that interior and facade normally complement each other, right? So I feel that in race of precision and time saving and maybe a cost aspect ratio, we are somewhere losing the intimacy of working with the facade maybe, right? Because the facade is worked by someone else. It's like giving a birth to a baby by someone and naming by someone. Like, so that intimacy between the who is actually designer of that building and who is creating a facade for that. So in race of, I think even FSI nowadays, because that saves a lot of space inside. Only maybe a 3-inch facade or maybe double skin, even if you go max 12 inches facade. So we are saving all the facades happen outside that periphery of built up area. So we should be very careful with how we use the facade softwares or maybe facade solutions in a way so that people can remember, because normal users or end users are always looking for some experiences rather than how glossy the facade is, right? How many buildings do you remember? If I go to, let's say, some temple, or if I go to some very 5-star hotel, what is a good memory will you have in a longer run? So normally that part as an experience or end user which has been missed. So that I think should be brought in somewhere.
True.
So we are talking about the integration of design and engineering and the site.
Yes.
In totality.
Right.
And
see, what I'll say is no AI can replace human brain and human heart, right? What feeling these two organs of human can bring in, no software can bring in basically, because they are basically set of rules which normally operate within set of parameters. Right. So that impromptu decisions or imperfection, which is, I think, will bring in more beauty rather than so precise solution to a particular problem.
Somewhere I think we lose the main fundamental or conceptual ideas which we have initially thought, and because of some restrictions or maybe not being educated totally about the materials and which we use in our buildings while designing. So yes, being an architect, I feel that somewhere we compromise. But because of this, softwares and visualizations and all, we are in a way back in the past, we had a lot of difficulty. Nowadays, I think we are improving a lot for the by realizing what we are going to deliver to the the culture, what we are building, how we are building, and what are the impacts once it get constructed. So all those aspects, maybe the positive side is that the after building getting executed, we know the pros and cons initially, so that we can add on few things which retain our ideas in a similar way.
I think a very two good examples we have in Ahmedabad itself is that Ahmedabad is lucky to have many great architects' works than anywhere else. One is I'll quote is I Am Ahmedabad, which has been designed by great architect Louis Kahn, and he was exploring the local material, which is brick basically. And I have heard a story that he asked the brick that what do you want to be, and brick replied, I want to be an arch. So naturally, then he came up with that beautiful language of I am, right, which has circular arches and many more exploration with arches. And one more building which comes to my mind is Mill Owners Association on Ashram Road, which has been designed by Lee Corbusier. So that brutalism or the strong impression of concrete has been diluted with the help of sun breakers, right? Because the sun is so harsh in Ahmedabad. And on the river side, he has totally kept vertical fins. On the south side, he had this angular fins, which gave him idea to develop that particular facade. So that intuition doesn't come with the software normally.
Actually, I would like to add on what he said, that collaboration. I think that's one of the very foundation of doing this project, because when we are doing the project, we no longer have to just mention about Revit models, because that's what people say. Then that's what people eventually end up handling to the client. But it's the entire process that we need to understand, that whenever a project starts, I think owners now needs to get on board with using cloud solutions, where there are like Autodesk Construction Cloud, where everything is hosted on cloud, and we have multiple consultants on board, which are given access to that project and the project files, and they are kind of also responsible for the models that they are preparing and for the discipline that they are in charge of. And in terms of those cloud platforms can actually assign issues, like, okay, you are working on, say, for example, exterior facade of something, somebody's working on the structure part of it, or somebody's on the MEPF sides of the thing, and they can actually see where each discipline is standing, and they can assign issues. Okay, there's a problem here, and this is the person responsible, and you can tag it, and okay, this issue is open, and they can revert back to it. So everything is documented, and there is a responsibility attached to it, and a timeline also which can be attached to it. And these platforms can eventually, make the whole process very transparent between the consultants and also to the owner.
So it's a very dynamic approach, and you are right, like it should be an ideal way, like all engineering services, facade consultants, structural people, they should be well integrated at time of consent. Right. They need not to do final detailing, but the awareness and the optimization and the knowledge sharing should happen. And platforms, what you are saying, like they really help, like in totally in 360 degrees.
Yeah. I would like to add what he has said. There are few projects where we worked locally as well as globally. So in India, when it comes, like as he rightly said, we have access for, facade part. We are taking, RCC consultant is taking care of his part. MEP is putting his elements. We are seeing a clash detection. There is a common consultant who is verifying everything and giving a result. And there is one part which Sir has highlighted in terms of, the tolerances we need to keep in mind. What tolerances when we are designing. And then we can decide the building lines related to this. And this stage has been done for the project, but when it comes to the execution stage, the person or the fabricator who has been appointed for this work, he doesn't have the capacity to integrate that facade into the model and, verify, because in our industry, as a consultant, we give intent details with dimension, but every contractor is having their proprietary system. They are detailing to a certain extent. Then at that stage, it has been finished by us, but when he is coming on board, he has not integrated, and at the end, we come up with some problems which we need to resolve later on during the execution stage, which these softwares are helping, but if we are utilizing it fully, instead of just at, stopping at some design stage, or execution has to be also integrated, which is not really happening. But certainly if we go Dubai, we had worked as a back office services where every submission by a facade fabricator has to be supported with BIM support. Everything needs to be updated, and architects are checking practically on BIM what is happening, the relationship with the other integration. Sometimes the visualizations what architect having with exterior, interior and other elements of the overall building are not understood by a facade fabricator to that extent, because of his scope is limited to exterior. So that is really going to help, and I think slowly we are heading towards this. It's our evolving stage right now. But really, it's helping us in taking a right decision.
That's so true. And yeah, with the change in scale, and we should be more responsible in dealing with our built products. And the individual owners should be there with all of us together. So yeah, this responsibility needs to be shared and taken up very consciously. So there are a lot of advancements happening in terms of not only designing and execution and the management, but also the maintenance part of the facade systems. Like drones have come in. There are printed facade systems now, where each and everything is predefined, pre-mapped, and like an automobile, the facade is well electrically integrated with all the sensors and things. Like we are moving ahead in that direction. So mindfulness, how to go about it, and thoughts on it.
I think a lot of owners are aspiring to use these technologies for their operations and maintenance part of their building cycle. I think what the overall cost in terms of building till construction is still just fraction compared to its overall life cycle management that we look into. We worked with Google, and they were very kind of experimental in terms of how to incorporate these technologies they started with their reuse department. It was real estate workspace, where we kind of modeled everything. Everything was tagged, and we had a unique ID represented for each element of their building. So with having facades in reference, anything that was physically there, it was virtually made, and there was a unique ID assigned to it. And anything, like you mentioned, they had a lot of sensors in place. So yes, drones can be futuristic technologies that can eventually come and help in that. But when it comes to current situation, they were using a lot of sensors to kind of monitor internal aspects of their building, where everything was, if there was going to be a retrofittation or any changes that was going to happen in a particular open space or open office of their particular area of that building, they had everything. We had developed a custom web-based tool for them where they were able to see everything digitally. So if they are going to do any retrofittation in terms of HVAC or electrical or anything, they were going to see, okay, this is the area that is going to be affected. For the facades, like I mentioned, different materials and panel systems were used, and everything was tagged. So if they were going to replace anything, they knew what material we are talking about or what size and shape we are talking about.
I think that data will help in the future to prevent the the maintenance part. Lots of building we see that not properly, maybe let's say a cleanliness because of the climate and the region where we are living. So yes, I think, and I'm hopeful that in future we might get those sort of technology that integrated. Let's say there is a vertical member in the facade, so the cleaning things will integrated into it, and by adding those data, periodically, after the certain period of time, it will clean automatic the surface. It clean the surface. So I think the maintenance part will get resolved in the future because we are running so fast towards it. So yeah, it's just an idea that that helps to do that.
I don't have any point to say on this, but I have a question for all my friends here who are facade designers. Why can't we find a material which, when it ages, it looks beautiful? Why the maintenance is required? Like if you see any of our old structures, they age gracefully and the beauty lies there. Basically, they are aging. For a human being also, maintenance is always required. But graceful aging is always a beauty basically. So why can't we find some solutions like that so that you have a different facades in each and every season so that you don't feel bored. Otherwise, nowadays there is an argument that building is looking so boring because there is a repetition, there is a monotony which is setting in, and then there is issue of maintenance, especially in our countries, third world countries, where there is a big problem of dust and sun basically. So you need to be cleaning up every alternate day or maybe every week. So why can't we find certain solutions? So even if after when it ages, it looks beautiful. So then by default, a viewer will see a different facade every time, and that will be a different experience every time. So that's a path, a question which to take forward for them to find put some money in research and find some solutions so that we don't get bored with the facade solutions.
Yeah. Just like a patina, good leather, that age is fine.
No, I'm not asking you. It is a question for all. It's open to for all basically. So why not? Because I've seen, like if we talk about cotton steel, right? The aging, when it rusts, it looks much more beautiful. Why not solutions where you have a different, like we have different seasons. So every time we feel, so we don't want people nowadays get bored very fast, right? So then there are like seasons. Every time there is summer, winter, monsoon. So we don't get bored. Similarly, why can't we find certain solutions where the facade gradually changes itself and doesn't remain a boring solution to that particular or a skin to that volumetric entity? Yeah, it's a question for why don't you put some more money in those research rather than only glass? Right.
So, Chirayu,
I've seen one beautiful building in Paris, which is I think Arab Institute, designed by I forgot John Novell. He has developed a screen which is a mechanical screen which operates on sun intensity basically. The sun falls on the surface, and with that it has apertures basically which operates. So you have a different light quality inside. So facade is basically generating a certain sense of experience inside also. So and that I think itself gives you a different feeling at the different time of day basically. So why not solutions to be found like this for a facade?
So that sort of kinetic facade.
Yes, absolutely.
Yes, I think we have this technology and we are adopting it fast.
Because if you go to US or somewhere, all the buildings look same to me. If you walk in a New York street, more or less all the buildings are same. Even Ahmedabad is, I think, rushing towards that direction. I don't remember those buildings. Which building is that? You have to put it in GPS and then only you'll find that particular location, right? Why can't we have identity to be created with the help of facade for that particular building?
Agree to that.
I'm just putting a question here. I'm not putting any point there.
No, but I think this is where digital tools helps us a lot. They give you the surrounding context, where my building is going to be, what my surrounding is going to be. Are there any other tall buildings besides me? Okay, let me also model that. Let's do a sun shadow study on this. How much amount of light is entering from this direction? So there is a lot that you can do. A lot of simulations that you can do, which can help you kind of create such unique facade ideas or kinetic facades ideas. And these tools are just helping you to achieve that.
Right, I think we are more focused on finding solutions of a problem rather than finding new ways to develop a facade. That is what I'm feeling nowadays.
Yes. So it's very nice to end something with a question in your head. Presently, we are running out of time. I would like to thank you all, and thanks.
Thank you.
Thank you.
Yeah.
Thank you.
Thank you. Please be on the stage for a minute, please. So that was a very informative presentation. We'll thank all the panelists for their insights. So just may I call Mr. Keswani from Aluplex to give a memento to them, please.
Good afternoon, everyone. I think a lot of people are outside. How do we call them? Let's have a huge round of applause for everyone. More loud so that everyone can hear we are starting something. Guys, faster. Louder, I can hear it. Wonderful.
So, thank you so much. So, without wasting any time, it is my privilege to call on stage Mr. Nitesh Shah and Mr. Brijesh Shah. They are going to showcase a very nice presentation about buildings. Thank you so much, sir.
Good afternoon. Myself, Nitesh Shah. I am Managing Director of Neha Designs and Project Consultant. Since from 87, we are in this field. Today, we are going to present our case study of facade for 3 buildings. One of the tallest building completed in Gujarat, in Gift City, Regalia. First case study we will discuss about the facade of the Regalia, then Orion, and then Capital 2. So I will hand over the mic to my junior, Mr. Brijesh Patel. He is a design director. Thank you very much.
Good afternoon. I am Brijesh Shah and design director at Neha Consultant. I am with Neha Consultant from last 18 years. Quick go through the bio. Nitesh Shah is the managing director of the firm. 2 huge experience he have in his entire career. जितनी शायद हमारी उम्र है उससे ज़्यादा उनका एक्सपीरियंस है. 40 years of experience in this line, in this field. करीबन 2,300 plus projects is completed in his entire career, and 75 million square feet area designed by him. 2 huge amount of area has designed in his entire career. These are some of project summary. The Capital 1, first 70-meter tall building in Ahmedabad in Science City, Sola. Then it's the Capital 2, the Arjun Skylife. It's a premium residential building. The law of podium, the first podium of Gujarat. The law of the podium is introduced in 2019 in Gujarat JDCR. But we designed and approved in 2014. The first project and the first podium of Gujarat is designed by us because the liaison is our master key. The V1 near the Bhopal Amli Junction, the Orion, the icon of the SG highway, Regalia by the Nakshatra Group, the heart of the Gift City. We'll talk about that. Vishwamya Foundation VUF Temple, the tallest temple of the world, 135-meter height of the temple, and such an interesting facade it has also. We are the regional designer for that. Now, coming to the main part. Regalia. एक दिन सर का कॉल आया कि तू कहाँ है? मैंने बोला मैं साइट पे हूँ. तो बोले तू 3 बजे तक आ जा, एक क्लाइंट मिलने को आ रहा है, मीटिंग है. वो हमारे क्लाइंट ने प्रोक्योर किया है गिफ्ट में प्लॉट, तो तू उसके लिए गए, इसका रिगार्डिंग मीटिंग है, तू आ जा. We met together, we discussed together which kind of building they want, which kind of retail, which kind of corporate their sector they imagine. Discuss करने के बाद the developer Pankaj Patel, he told me that ભાઈ આપણે એવું બિલ્ડિંગ બનાવવું છે કે આખા ગિફ્ટમાં ક્યાંય ના હોય. And I took that word. અને એના પછી after 3 to 4 days, he told me that at that time कि we'll share your AutoCAD soft copy within 3 to 4 days. तो अभी अब डिज़ाइनर का क्या होता है कि अगर कोई बोल के जाता है कि डिज़ाइन करना है, चाहे प्लॉट भी नहीं है, फिर हमारी दिमाग की बत्ती चलती जाती है, तो हम उसी दिमाग के अंदर घोड़े अपने लगते हैं कि ये मुझे ऐसा डिज़ाइन करना है, ऐसा डिज़ाइन करना है, मैं ऐसा डिज़ाइन करूँगा. तो पार्ट ऑफ दैट 3-4 दिन की पूरी मेहनत, पूरा दिमाग रात में सोते हुए भी वही ख्याल है कि क्या डिज़ाइन करेंगे, और कई सारे स्केच बना दिए विदाउट प्लॉट कि कुछ ऐसा करेंगे. 3-4 बाद उनकी प्लॉट आई, और आफ्टर 3 to 4 days मैंने सर को कॉल किया कि सर आप कहाँ हो. सर ने बोला कि मैं एक जगह पे मीटिंग में हूँ. मैं बोला आज अभी आप आ जाओ. तो बोले क्यों? मैं तो आप आ जाओ, बाद में बोलता हूँ. मैं उतना नर्वस हो गया. उनकी प्लॉट आई और हमको जो फ्लोर प्लेट मिली वो थी सिर्फ 120 फीट बाय 120 फीट. सर 4 दिन सोचा कि ऐसा करेंगे वैसा करेंगे, और हमारे पास सिर्फ 120 बाई 120 की फ्लोर प्लेट है, हम क्या बनाएंगे? ये तो ओडा एमसी की वजह से अपने को जैसे 2 फीट की प्रोजेक्शन मिलती है वो भी नहीं मिलेगी, तो क्या करेंगे? और मैं पूरा डिमोरलाइज हो गया एट दैट टाइम, आई एम टू मच नर्वस। और सर ने स्केचिंग स्टार्ट की, बोले कि जो नहीं है उसको सोचो मत, जस्ट टेक इट एंड उसकी पॉजिटिव सेंस को कन्वर्ट करो। सर ने स्केचिंग स्टार्ट की, एंड द मोस्ट ब्यूटीफुल थिंग इन दैट पार्ट इज दैट कि हमारी जो प्लॉट की लोकेशन है वो कैसी है, तो दो रोड कॉर्नर पे है, सो रिटेल एक्सीलेंट। गिफ्ट 1 और 2 जस्ट बिसाइड ऑफ गिफ्ट 1 एंड 2, तो उन्होंने एक फ्लोर की प्लेट रखी, साइड 2 रोड कॉर्नर है, तो कौन से फेसिंग पे है, नॉर्थ और ईस्ट, तो सन डायरेक्ट सन कभी हार्म नहीं करेगी, तो हम कुछ भी प्ले करना चाहे उस फसाड में तो हम डेफिनेटली कर सकते हैं। देन वी बाउंड्री 120 by 120, वी रेज इट अप 122 मीटर्स, एंड हमको फ्लोर प्लेट में हाइट ज्यादा देनी थी, दैट्स व्हाई वी कंसीडर्ड 29 फ्लोर्स। जब पार्ट हो गई बन के, नॉर्थ ईस्ट में अपने को टॉल पार्ट 22 मीटर की हाइट का मिल रहा है, चारों साइड का व्यू जो है वो एनहेंस अपने को 2 रोड कॉर्नर की वजह से कर रहा है। देन वी सेग्रीगेट 29 फ्लोर्स, देन वी डिवाइड 120 feet into equal divisions and emboss together. Then conventional grid we achieve this one. Then अभी बाहर तो निकलना नहीं है, सामने से तो कुछ लगाना नहीं है, तो उन्होंने सबसे पहले वही बोला कि अपने ऐसा कुछ करते कि जस्ट प्ले विथ इटसेल्फ। अगर आपके पास बाहर से लगाने के लिए कुछ भी जगह नहीं है तो आपको क्या करना है कि आपके पास जो भी प्रोफाइल है, पर सर मैं बोल रहा हूँ अब एफएसआई कैसे, एफएसआई के बिना तो डेवलपर भी नहीं मानेगा, तो एफएसआई भी नॉट यूज करना है, प्रोजेक्शन भी कवर अप नहीं करनी है। आफ्टर ऑल दैट वी स्टार्ट वर्किंग ऑन दैट, जस्ट वी डिफाइंड 3 floors फॉर रिटेल। अभी रिटेल और ऊपर के कॉर्पोरेट को सेग्रीगेट करने के लिए वी डिफाइंड ट्रिपल हाइट ग्राउंड फ्लोर एट्रियम, एंड आफ्टर वी जस्ट टूक 1 amenity floor, and for cut down the massing for upper floor and lower floors we just put a sky garden in that area. That becomes an entire entity which entire amenities floor will be converted with to triple height sky garden. वो sky garden भी हमने नॉर्थ फेसिंग पे रखा, जिससे हमें स्पेस अच्छे से यूज करने को, अच्छा व्यू और डायरेक्ट सनलाइट हमको हार्म ना करे। उसके बाद जस्ट वी रिसेस द प्लेस, जस्ट वी रिसेस द सरफेस, हम मास के साथ प्ले करते गए, समथिंग लाइक दिस, देन नेक्स्ट और देन नेक्स्ट। आफ्टर ऑल दी एंटायर फसाड रिसेस वन, एंड ज्योमेट्री के साथ प्ले करने के बाद हमको कैंटिलीवर बॉक्सेस मिले हैं। जो कैंटिलीवर बॉक्सेस है, मैं अगर इनसाइड रहता हूं तो मुझे 3 साइड ओपन स्पेस वाली ऑफिसेज मिल रही है, 2 साइड ओपन स्पेस वाली ऑफिसेज मिल रही है, और वो मेरे लुक्स को भी एनहेंस कर रही है। तो वही प्रोफाइल में इटसेल्फ मासिंग के साथ प्ले करते हुए हमने रैंडम पॉकेट्स में कैंटिलीवर बालकनीज के साथ कैंटिलीवर ऑफिसेज, और उसके साथ जो अपर की फ्लोर मिल रही है मुझे, उसको अपर फ्लोर जो है, जो उसकी टेरेस और बालकनी में कन्वर्ट हो सकती है, उसके हिसाब से कन्वर्ट किया। फिर वी अप्लाइड ग्लास मास, और पूरी ग्लास को डाल के मॉडल में डालते हुए बैक या कुछ ऐसा प्रोजेक्शन हमको मिला। देन फर्स्ट आई शेयर्ड विथ मितुल भाई, और मितुल भाई ने बोला कि ये क्या बना दिया, इतने सारे टुकड़े 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 फसाड में कर दिए, वो अलाइनमेंट में लगाने के लिए कितने टास्क रहेंगे तुझे पता है? मैंने सर बोला आप हो तो कर देंगे, अब साथ में मिलके भी कुछ ना कुछ तो नया करेंगे, क्योंकि मुझे सिर्फ ऐसा डिजाइन बनाना है जो गिफ्ट में नहीं है। दैट्स व्हाई आफ्टर दैट मैंने पूरी जो साउथ फेस थी उसको पूरी यूटिलिटीज में कन्वर्ट कर दिया। यूटिलिटीज है, सर्विस एरिया है, उसको पूरा साउथ में ले लिया। नॉर्थ ईस्ट जो पोर्शन है उसको बालकनी वाली टेरेसिस और ऑफिस जो नॉर्थ ईस्ट फेसिंग है उसको एनहेंस जो व्यू मिल सके उस तरफ से डिजाइन किया। और जो गिफ्ट 1-2 की टावर है ऑलरेडी मुझे शेडो दे रही है मेरी वेस्ट फसाड के लिए। तो कुल मिला के बैकएंड को सर्विस में डाल के पूरी ईस्ट, वेस्ट और नॉर्थ तीनों फसाड को हमने एक एंगेज इंटरमीडिएट फॉर्म में डिजाइन किया। जस्ट प्ले विथ क्यूब्स एंड जस्ट प्ले विथ मासिंग इटसेल्फ। तो हमारा परसेप्शन ये हो गया, हमने ये बिल्डिंग 3D के अंदर फाइनली डिजाइन किया। उसके बाद डिजाइन करने के बाद पार्ट ऑफ एग्जीक्यूशन, सॉरी we do internal test, structure analysis, daylight analysis, acoustic analysis, thermal performance analysis, material system performance checking. विंटरनल टेस्ट के बतौर हमको कई सारी जगह पे विंड प्रेशर के बतौर 2.75 kpm, तो उसके हिसाब से हमको कई सारी पोजीशंस चेंज करनी पड़ी। जो मितुल भाई ने भी हमको साथ में मिलके पोजीशन और बिल्डिंग की जो मास थी जहाँ पे विंड प्रेशर ज़्यादा आती है उसके हिसाब से पूरी मास को वापस से कन्वर्ट करना पड़ा। फसाड मटेरियल में हमने 100% हम पहले से श्योर थे, नथिंग अबाउट दैट, शुको इज द बेस्ट ऑप्शन, दैट्स व्हाई वी यूज एंटायर शुको। अभी जो जंक्शंस बन रहे थे एट द टाइम ऑफ एग्जीक्यूशन, 2-4 छोटी छोटी चीजें ऐसी थी, इसकी अनइवन सरफेस थी, तो फसाड इंप्लीमेंटेशन इज द मेजर टास्क। अगर मोनोटोनस ग्लेजिंग होती है तो अपने दिन के अंदर करीबन 25-30 पैनल्स आराम से लगा सकते हैं, पर हम इसमें कैलकुलेट करना बहुत टास्क था, फिर भी हमने 7 to 10 पैनल्स कंसीडर की। बट फसाड एप्लीकेटर डिड अ गुड जॉब। कई जगह पे हम कम पड़े, पर कई जगह पे उन्होंने एफर्ट डाल के उतना अच्छे से काम किया कि हमको टाइम लाइन में खत्म करके दिया। दैट्स द पार्ट, एंड एंटायर टीम वर्कड वेरी नाइसली। ये प्रोजेक्शन निकालने के बाद इसमें टास्क थी कि हमने कैंटिलीवर ऑफिस बाहर निकाल तो दी, पर उसकी रेन वाटर कहाँ से लेके जाएंगे। तो व्यू स्मार्टली हमने सिर्फ फसाड की जो प्रोफाइल है उसको यूज किया। फसाड के जो मलियंस लगते हैं और बैकएंड की कॉलम है, हमने बैकएंड की कॉलम और फसाड के मलियन के बीच में से रेन वाटर को पूरा ट्रांजिट करके फ्लो निकाला। देन हम जो डिजाइन पहले से करते हैं उसमें हम कई सारी चीजें जो है वो पहले से ध्यान रखते हैं कि सर्विसेज कहीं से दिखनी नहीं चाहिए, उसकी मेंटेनेंस, अगर ग्लास बिगड़ गई, ग्लास को चेंज करना है तो व्हाट द ऑप्शन, वी आर प्रोवाइडिंग स्पेस फॉर पीओडी क्रैडल एंड BMW क्रैडल फॉर बोथ। जो ऊपर से आती है 3-3.5 मीटर तक अंदर जाती है, और वो अंदर का ग्लास अगर क्लीन करना है, अगर आगे जाके कुछ दिक्कत आती हो तो अगर चेंज करना है तो वी कैन इजीली डू दिस एट टाइम। ये 3.5 मीटर तक अंदर जाके अपने को हेल्प करती है। तो वी डिड नॉट काइंड ऑफ दैट कि सिर्फ सोच के बना दिया, उसको मेंटेनेंस के बतौर भी एडवांस में सोच के हमने उसकी प्रोविजन रख के डिजाइन किया। दिस इज द स्टोरी, एंड फॉर दैट मैं ये पूरा बिल्डिंग का क्रेडिट सर को तो सही, पर पूरी जो टीम है, टीम PMC, हाईटेक, साई फैब्रिकेटर और फर्स्ट ऑफ ऑल सुको, और सबको थैंक्स बोलना चाहूँगा कि उन लोग ने इतने अच्छे से हमारे बिल्डिंग को डिज़ाइन किया। हमने तो डिज़ाइन किया, हमने सिर्फ सोच बनाई, पर आपने अच्छे से उनको वहीं पे इम्प्लीमेंट किया। आज कोई भी गिफ्ट से जाता है तो बिल्डिंग की फ़ोटो निकाल के मुझको भेजता है कि थैंक्स, very beautiful design. So thank you for that. Thank you for everything. And same, so capital 2. It's also unique facade. Just we played with mass and cubes, vertical and horizontal. So vertical palette and horizontal palette club with each other. So हम हमारी बिल्डिंग में ट्राई करते हैं कि कोई भी सर्विसेज जो बाहर से ना दिखे। सो वी प्लान अकॉर्डिंगली। हम कई सारी बिल्डिंग्स जो ऑब्जर्व करते हैं जो हमारी पुरानी डिज़ाइन की हुई है उसमें हमको वर्टिकल शाफ्ट दिखती है, एसी के लोकेशंस दिखता है, तो वी ट्राइड कि वी कैप हमने ही जो गलती पहले में की है वो हम दूसरे में ना करें, तो इसके लिए सेपरेट शाफ्ट्स की प्रोविजन रख के उसको भी एलिवेटेड, अगर ये फसाड देखेंगे तो साइड में जो मोनोटोनस फसाड है उसको क्रॉप करने के लिए हमने सेकेंडरी प्रिलिमिनरी सेकंड पार्ट के अंदर वर्टिकल क्रॉप्स में, तो इसकी बेनिफिट भी क्या है, अगर अहमदाबाद के क्लाइमेट तो देखे तो फुल ग्लास वाले बिल्डिंग जैसे गर्म भट्टी हो जाती है, तो फॉर कट ऑफ द मास वी ट्राई टू प्ले विथ मास, vertical mass, horizontal mass. There's the impression 1, 2, and 3. Oh, and it's 3. Yeah, I think it's a little bit. This is the night vision as per far end. This is the Orion. Orion is landmark building on SG Highway near Lotus Temple. सेम ये केस में भी हमने नॉर्थ ईस्ट साइड में पूरी ग्लेजिंग यूज की है क्योंकि वो SG Highway के टूवर्ड्स है, तो दिन में कभी भी डायरेक्ट सनलाइट हार्म नहीं करेगी। आफ्टर दैट इसमें भी हमने जो नीचे का कमर्शियल पार्ट है उसको वर्टिकली ग्रिड में ट्रीट किया है, ऊपर के बॉक्सेस को हॉरिजॉन्टली ट्रीट करके मासिंग के साथ प्ले किया है। अपार्ट ऑफ दैट साउथ वेस्ट फसाड में हमने ग्लेजिंग को स्टॉप करके पूरी जो फसाड है उसमें वर्टिकली पिंस के बतौर जो सनलाइट को क्रॉप करे और डायरेक्ट सनलाइट कभी भी इनसाइड लोकेशन में डायरेक्टली हार्म न करे उसके हिसाब से वर्टिकली ग्रिड में ट्रीट किया है, और उसको बाहर से दिस इज द माई विच इज द सेंटर पार्ट, उसको हमने पूरा HVAC का डक्ट बना के उसको बाहर से एस्थेटिकली ऐसे कवर अप किया है कि इट्स पार्ट ऑफ फसाड लगे, उसको अलग से ट्रीट करने की जरूरत नहीं थी। दिस इज द Orion, a short summary for that. Thank you so much. Thank you.
Very nice presentation, Brijesh bhai. You forgot to mention the glass vendor. We were the glass suppliers, so we also contributed a little bit for this building. Thank you so much. So up next, let us call the blue-eyed boy, a Gujarati person who is from, I think you are not from Ahmedabad, but in a recent time he has done a lot of good projects. And one thing I know for him is that he's designing buildings with very high specification. So let us give a warm round of applause for Mr. Vicky. Thank you so much.
Thank you, Shalin, for your kind words and making me feel younger once again. All right, so it's a privilege to be here amongst the industry leaders, the architects, developers, facade engineers, and the facade professionals from the city and around the country. I'm very excited to present one of our most technically challenging projects, which is also visually distinctive than many projects what we come across. This project has challenged us to think beyond the flat lines, and hence the title of our presentation is Defying the Plane, the Sculptural Non-Linear Geometry of ICM Kozhikode. Now, let me give you a short background of the project before we deep dive into the technicals of the subject. This project is located in Kozhikode, which happens to be an historical city in the on the Malabar coast. The first international cooperative museum was built in 1844 in Rochdale, the UK. So this project, ICM Kozhikode, becomes second of its kind on the world map. So this city, the state of Kerala, has seen the strongest cooperative movement spanning across banking, real estate, education systems, and many other community-based economic systems as well. So the vision was that this project should stand out as a education center, as a communal, cultural landmark, and also a global platform for displaying the cooperative movement. Now, this project, as per the design philosophy, this project is divided into two parts. The lower base, which I call the prism glazing, it shows like an anchor to the building, a solid mass at the bottom, and the top portion of the building, which is reflecting the dynamic structure, the fluidity, and it engages with the skyline. So the dialogue at the transition, where we have this prismatic glazing and the top facade, creates a dialogue which is going to be like the lower portion is going to engage with the pedestrians and the top portion merges with the skyline. And hence, as a combination, we get an architectural marvel there. Now, we are walking through the technical aspects of this project. So here we had two typical types of glazing. The lower mass, which I keep telling as a prismatic glazing. In this facade, we had, of course, the challenges with regards to logistic. The huge panels spanning about 4.8 meters had to be installed in the inclined downward direction, and also the similar panels were coming on the top. But more critical was to understand the load transfer which are going to happen through the facade and the loads which this facade is going to take care of. So here we had challenges of wind load, but more than that, the challenge of catering the dead load, the building movements were more far critical. So what we had to do here is, first of all, the system was taken as a strict glazing system. Now, since the facade is inclined from top, and architects and client did not want to have any pressure plate capping on the top, so just leaving it to the mercy of the first barrier gasket would have been one of the biggest mistakes which we could not afford for. So here we had to go with a closed joint system, and also the depth of the profile was required higher because there were self-weight. The reactions were coming in not the linear directions. So this void cavity helped us to increase the depth of the profile and also take care of the structural loads. Laminated DGU was taken consciously to ensure that the slope surfaces which are there, the glass, in case of any accidents, should not leave the frame, should not leave the panel and cause any casualty for the people below. Spatial extrusions were designed at the junction locations to ensure that the glasses merge and they come in one plane as desired. A blow-up assembly, how this assembly is connected. We have a transom to which we have got the adapters connected, and then we have the first barrier gasket. The DGUs are lami DGU which have this U channel embedded in the DGU form, and the toggle takes care of mechanical engagement of the panel with the profiles. Like I said before, the dead load, the building movement, the dead load was one of the critical aspects of designing. So what we did here is, we transferred the wind loads on the top and the the dead loads on the top and the bottom. The mid profile, the corner junction, what we see here, had this dead load provision, wind load provisions. So whatever vertical movements were happening were taken care at this junction. Ideally, what we do is we span one mullion within the floor, and from here we consider a second mullion. But while designing, taking into account the building sway movements, what we did is we designed the entire mullion as single entity and having this center portion with the vertical slots. So if there's any movement which happens at top and bottom, the building profile does not change from the top and bottom. Thus the center slot takes care of those movements which happens vertically. At the junctions, just to ensure that this acts as a monolithic assembly, a good sized of MS inserts were embedded in the profiles which were mechanically connected to ensure that this acts as single entity. And this is how the lower prismatic glazing looks like in the real scenario. Now, the lower portion looks more challenging in the first glance, but there were further more challenges which were going to come up for the above portion. Interior views for the lower areas. Now the above portion, if we see very carefully, none of the corners are parallel to each other. The reason here was, from this floor plate onwards until the 11th floor, every floor plate is drifting by 1 degree each. So when you have this drift happening by 1 degree in the civil, your facade is going to be also in a different direction. The lower floor, one point is going to be inside, and the subsequent point on the right hand side is going to be outside. So virtually you see a twist which is going to happen on the entire facade, because exterior has to go seamless irrespective of your floor plate movements. So if this had been a straight floor plate, the 90-degree angle would have gone in this direction, what you see. But because of the twist which the client and the intent had called for, there was a different arrangement which was required to ensure that the building, the facade goes along with the building slab edge. The image on the right hand side which you see is about twisting the facade, how this bending had happened. So now the design process, how did we evolve about the design process, what precautions were taken, what measures were taken to understand the twist which is going to come. Now we had to first model the entire building on the Revit model to understand what is the twist which you are going to get on the subsequent floors. And then, now there are different ways in which you can get a cold bend panels. One is you can bend the entire unitized glazing and then get the bent glasses from the factory. That is cost, it's going to cost you an enormous amount, and also in terms of timelines, it's going to consume a lot of time. So second methodology was that let us get these panels, bring them to the locations, and depending on the dimensions what we got from the site survey, and also depending on the measurement what we are getting on the Revit model, let us mechanically cold bend the panels at the location. Now the system. In unitized system, we have two types of system. One is the male-female system, which is conventionally used on many projects. Other is the female-female. Now, since we had to add a twist between adjacent and subsequent panels, so male-female system would always have obstructions at the engagement areas where the aluminum profiles are going to collide. So the flexibility of twisting the panels becomes little difficult when you have a male-female system, but that same flexibility we are able to achieve in your female-female system. Now, one more advantage what we could derive from this system is, here we have an aluminum edge guard which is going to be exposed to sun. Now, due to conduction, the heat is going to get transferred from the profile, from the edge of this profile towards the interior. So my entire U value of the system is going to increase. Simultaneously, the silicon edge what we see over here is also going to be prominently seen in the elevation. However, the system what we adapted was, the edge guard is a silicon gasket, and the silicon gasket is directly embedded with the glass edges. So virtually we do not see that silicon bite between the profile and the glass. The same study, further to substantiate what we said earlier, a flexo analysis was done to understand the U value of the entire system, giving the same parameters of the exterior condition, the glass U value, but you could see the difference between only the mullion profile if I put it across. So when we combine all the mullion, transom, other profiles, we could see at least 30 to 40% lesser heat transfer through the facade towards the interior premises. Designing the glass, we had to be conscious that once the glass is bent, the profiles once they are bent, they should not have a spring back action, and the profiles and the panel should not again come back in the same position as they were initially. So a sufficient amount of reserve strength had to be ensured to be kept within the glass and also the profiles. So we had used two softwares for determining the strength of the glass. One was SJ Mapla and other was STAD. Now, SJ Mapla, we have a limitation that we cannot have a parametric geometry within the glass analysis. So a combination of both were being used across to ensure that we have a safe deflection values and a safe stress values. Now, in Mapla, we have a provision. We can take into account the thermal stresses. We can input the value of the exterior weather conditions and also the interior comfort condition. The delta between the two is used as an input in this software. general assembly, how this entire system works. We have your identical mullions with the first barrier coupling gaskets, the edge guard which is again silicon gasket. And this is how the twist was happened. Now, depending on the scale what we had drawn on the Revit model, we could understand that the twist at majority of locations was coming to plus or minus 20 millimeters, except for the corners where the twist was going up to 45 millimeters. So those twists were achieved on the site by using a conventional jack and assembly, which we can see on the right bottom image. So each panels were mechanically bent at the site location, and just to further exaggerate this entire assembly, this entire fabrication installation was done by a local contractor in Kerala. We had to do a lot of hand holding, a lot of trials were run, a lot of mock-ups were prepared to ensure that the twist, which is what we need, we are able to achieve it. So this is the virtual image, what you can understand. Before bending, the profiles look like this when they are parallel to each other. After the twist, there's a certain opening up which happens in the profile, which again is being taken care by the coupling gasket so that the first barrier does not open up. Now, we also had to ensure that the stringent parameters in terms of distortions, in terms of roller wave, had to be given to the processor to ensure that even after the twist, the glasses look flat plane. On the first and the second image, you could see the reflection of the neighboring building. The glasses are flat. And the third image is the view from inside, which we can see how the twist is virtually seen or is physically seen when we are standing at the location. Corner profiles from inside, like I said, since they are twisted, none of the panels are vertically straight, they all are inclined, and the junction becomes more critical when you have two different angles coming and joining at that point. So yeah, that's all from my side. Thank you so much for being such a patient audience. Thank you.
Thank you, Vicky bhai. That was really insightful and very nice designs. So let us call upon stage Mr. Deepak from Jotun. Please welcome him with a round of applause. Thank you. Big round of applause. Thank you.
A very good evening to all, and it's a pleasure addressing the audience here in one of the fastest growing cities in the country, Ahmedabad. Today it's a very special day for Jotun. Special and a very emotional day because we have completed 100 years today. And it's been a long journey. It's been 100 years of glorious, 100 glorious years, 100 years of protecting properties. With humble beginnings in Norway in 1926, we have moved on to an organization which is more than 10,000 employees strong, 40 manufacturing facilities across the globe, and 7 R&D facilities. We are trusted by the world's leading developers, consultants, and architects, and the trust has led us to be part of 14 of the top 20 tallest buildings dotting the globe today, including the Burj Khalifa, which is the tallest building in the world. We started with, marine coatings and then gradually moved on to other departments like decorative, protective, and powder coatings. Today, we are mainly talking about the architectural powder coating segment, and without taking much time, let me get into a bit of technicalities with respect to powder coatings. Durability of the aluminum profile or aluminum coatings is defined by broadly the AMA specs, which are very prevalent in India. So there are 3 broad specs: AMA 2603, AMA 2605, and AMA 2604 and AMA 2605. Corresponding to these specs, we have Jotun Facade, which offers 15 years of guarantee, which is very prevalent in the market. The market is now slowly adapting the AMA 2604 specs, and most of the critical and the iconic projects are AMA and AMA 2604 specs, which is Jotun Super Durable, offering 25 years guarantee. And now, the latest and the most, the harshest of the specs is AMA 2605, where we have Jotun Durasol offering 30 years of guarantee. I think there is no introduction needed for this particular iconic building in the world. It is Burj Al Arab, right in the middle of the ocean, in harshest of the desert conditions. This has used Jotun Super Durable Series, which is the 25 years AMA 2604 category powder, and it has withstood. This was quoted in the year 1998, and today we have seen the entire 25 years life cycle of the powder cross, and it is still standing good. We had the opportunity of measuring the project as to how it has been performing. The last measurement was done in 2017. We retain a master panel at the beginning of the project, which was in 1998, and if we still compare with the performance of the coating today, the coating is still very intact, and this is one of the first projects which has actually crossed the entire 25 years guarantee process and still going good. Next, we come to the ultimate in protection, in durability, ultimate in terms of the aesthetics that it provides, and with the sustainability angle as well, Jotun Durasol. When we talk about Jotun Durasol, which is the AMA 2605 spec, we have to compare it with the liquid PVDS systems which are available in the market. So there are a few similarities and differences. First, if we look at the similarities, both are AMA 2605 specs. They comply with AMA 2605, and they both use a fluoropolymer resin. That's where the similarity ends. Apart from that, if you see, it is a single coat system. Durasol is a single coat system, 50 to 70 microns, whereas liquid PVDS systems are 2-coat or 3-coat systems up to 45 microns. Durasol is a sustainable product, low on VOC, and very much efficient in application as well. Since it's only a single coat system, the application costs are also less. And most importantly, it offers 30 years guarantees versus 20 or 25 years for a liquid PVDF systems. Now, when we talk about guarantees, what does it cover? It basically covers 3 broad aspects. One is the color retention. The color has to stand for the entire 30 years. The gloss retention. The gloss of the gloss of the shade has to withstand for the entire 30 years, and the film integrity or the durability of the film, it has to also withstand for the entire 30 years. How do we ensure that? That is where we have the Jotun Approved Applicator Program. As part of the Approved Applicator Program, we basically audit the process of an applicator for the systems that they have, and they also have to undertake a long-term testing in our regional lab in Dubai, where it has to undergo the acetic acid salt spray test, which is considered to be one of the harshest tests that a powder coating can undergo. Once it gets cleared, that is when we offer the approved applicator certificate to a applicator. This ensures that out of the thousands of applicators that are there in the market in India, we have the best set of applicators who are coating for your projects and are giving the best quality that you require. Today, we have around, say, 30 approved applicators, about 7 applicators for Durasol, and about 26 applicators for Super Durable across the length of breadth of the country. Now, we spoke about the durability aspect. Powder coatings also has a very, very important aspect, that is aesthetics. Powder coatings can be offered in a range of finishes that includes metallics, the Sahara finish or the fine texture finish, the wood spiration or the wood coating finishes which are very popular in the market, and the cool shades. Today, we will mainly focus on the cool shades since sustainability is the buzzword today. Cool shades are nothing but it includes a pigment which helps in reflecting the heat incident on the powder coated aluminium. Therefore, there is a less amount of heat transfer from the outside to the inside, thereby reducing the heat transfer inside and also reducing the heat island effect in the nearby areas. There are a couple of projects that has been done, not in India yet, but there has been Indian units which has been supplied to projects abroad. One of is the Mazoon Towers in Qatar, and the Louvre Museum in Abu Dhabi is also a cool shades project. When we talk about powder coating, sustainability is not far away. Since there is no use of solvents, it is completely a very sustainable product, less than 2% VOCs, which can be given in certification, and they are compliant with most of the best of the green standards which are available in the market. Some of the references that I would like to take you through quickly. This includes the Sybage IT Park in Ahmedabad. This uses Jotun Durasol. It has been done by HiFab. DLF Downtown Chennai, which is under execution, done by innovators. This is Jotun Super Durable. Jotun Super Durable again used in Juno Moneta, which is an Aluplex project. The Kohinoor World Towers, which is under execution and towards the completion stage. This is also using Jotun Super Durable. Glazium is the facade contractor. We have done a range of infrastructure projects, which includes the Mumbai Airport, the Common Central Secretariat, or the CCS Delhi, then the Noida International Airport, which got recently inaugurated. This also uses Jotun Durasol, the AMA 2605 compliant powder. Apart from that, a range of commercial projects, including the Grava Business Park in Hyderabad, ITC Greens, Bangalore, the TCS Trivandrum project, TCS Chennai project, and to name a few more, Foxconn in Bangalore, which has been a massive project for us, not just in powder, but in intermission coatings as well. Google Hyderabad is also recently started, and we are currently executing with glass wall systems. And we have done a range of residential projects, includes Purva and Oberoi, etc. as well. That's about from our end. Thank you very much. Yeah.
Thank you, Deepak. That was an amazing presentation, and congratulations for 100 years of Jotun. So now may I call Mr. T.S. Aditya on stage. He's part of Qton.
Good evening, one and all. I'm Aditya. I represent iClad, which is the facade division of Qton Ceramics. So our topic for today is sustainable cladding solutions for high-rise buildings. The key intent of the meeting is to understand what should be the selection criteria for materials, especially for cladding when it comes to high-rise projects. Let us understand what are the tallest buildings available in the world. So if you look at worldwide, the tallest being Burj Khalifa, which is around 828 meters. In India, the top 3 buildings are based out of Mumbai. The Palace Royal, which is almost 320 meters and 88 floors. Lokhandwala Minerva, which is about 310 meters and 78 floors. So what should be the criteria for being considering a building to be a high-rise? If a building with an occupied floor that is more than 75 feet above the lowest level of fire department access is called a high-rise. When it comes to high-rise buildings, everyone wants to use sustainable products. When you talk about sustainable products, the first thing that comes to your mind is terracotta, probably engineered stone, timber, which is a wood-based product, or some bio-based composites, or maybe natural stone. Because these are sustainable products and these are not, do not have any specific kind of coatings on the top. But the question is, how do you make sure that you are selecting the right product? So when it comes to the key features of these kind of eco-friendly materials, one thing is they are very energy efficient. They have the capability to withstand any kind of climate changes, especially with a tropical climate like what India has, where you have seasonal changes after every 3 months. It is very difficult to ensure that it can withstand the harsh UV rays. So the product has to undergo a number of cycles and maintain the same kind of aesthetic appeal that it has during the stage of installation. At the end of the life cycle, recyclability is also a major factor. How can we reduce our carbon footprint in order to make sure that we do not burn too much of fossil fuel in the manufacturing process, and also in terms of disposal of the material after the life cycle? So in any kind of exterior grade product, the first thing that comes to you when you're looking for a high-rise building is, how does it perform against fire? And how does it sustain for a longer period of time? So the selection criteria should be, the product should be either A1 or A2 or B as per EN 13501 part 1 with respect to fire rating. And when it comes to UV, it should pass EN 438 part 2 and part 6. And the contrast and grayscale should be above 3 and 4 in order to be considered an exterior grade product. If these criteria is not met, then it may not be the right product for your facade application. When it comes to installation, it should be routed through a trained facade contractor who follows the proper shop drawing, which is approved by a facade consultant and architect, and the necessary tools and accessories have to be used during installation. A lot of times what happens is product manufacturers also come up with solutions on how the product can be correctly cut, installed and treated. So until and unless the contractor also understands the details and the intricacies involved in the installation process, it may not work out the right way. All material manufacturers should also engage in training programs which ensure that the subcontract teams of the contractor is also trained. Most of the times the contractor is aware about it, but most of the subcontract teams are not on the payroll of the contractor. So when they are hired, some of them may not even know how to install the product. So they try to understand from their group head to fix it in the right way. But until unless they undergo a proper rigorous training process, things may not work out the right way. So when it comes to facade systems, the intent of having a double skin facade is to get some kind of additional benefit, right? So it should be more energy efficient. The systems that are available is either rear ventilated facade system or a rain screen facade system. So how do you call a facade system a rear ventilated facade system? It is when you have a cavity between the exterior double skin panel and the wall, which is around 20 mm, and there's a vent on top and the bottom, which is around 20 mm. So what happens is when hot air enters the facade through the vent at the bottom, hot air being less denser, it has tendency to rise up. The same concept as a hot air balloon. Hot air balloon floats up because air when heated becomes less denser, and that's the reason why the air is going to circulate in the cavity and then it is going to vent out from the top vent. So this criteria ensures that there is a lot of advantages. One thing is it acts as a thermal barrier. It ensures that the load on air conditioning is substantially reduced. It makes sure that all the cracks which are formed are sealed. It is concealed rather. The framework acts as bracing. It ensures that the system is more stronger. And last but not the least, it gives you substantial noise reduction also in terms of decibel value. So when it comes to fire performance, fire is an exothermic process. Every product, irrespective of the nature of the material, may undergo some stage of the graph which is shown here between temperature and time. For example, if you take an A1 grade product, which means that it never undergoes the phase of ignition. That means no component of the product can get burnt. When it comes to A2, certain parts of the material can thermally degrade, but it does not reduce the integrity of the panel. For example, if you look at glass wool is made up of glass beads which are fixed to each other using an adhesive. The adhesive can thermally degrade, but the product will not still remain intact. So when it talk about class B materials, they are flame retardant products, which means as long as you have the point of application of flame, it burns. The moment you remove the point of application of flame, the fire retards by itself. So if you look at any architect or consultant, typically their mindset would be to go for a product which is sustainable when it is exposed to fire, and at least it should be minimum B class. Once you go from C to F in the ascending order, the time it takes to go from the growing fire stage to the flashover potential is very small. So when you go from C to F, the exact time phase what it can take is somewhere between 5 to 10 minutes, not more than that, which means even before your, your interiors, whatever is catching fire and then fire is getting exposed outside to the dead load openings in the wall, even then, before even your interiors totally catch fire, your exterior is going to fail. Your facade system is going to fail. Now, there are different standards when it comes to fire. A lot of people talk about European standards, ASTM standards, and British standards. It's very difficult to establish which one is more effective and which one is more efficient, and how do we correlate between the codes of different standards. So whatever is EN 438 as per European norms, whatever is BS 476 as per UK norms is same as ISO 1182 as per European norms. So whatever is class A1 and A2 is classified as per UK norms as combustible, non-combustible and limited combustibility materials. Similarly, when you look at ASTM norms, whether it is class A1, A2 or B, still forms under the classification of class A only, because the fire spread index for a limited combustible product or class A1, A2 or B is around 15. So if the flame spread index is between 0 to 25, it is still considered as class A as per ASTM norms. So my conclusion is that A1, A2 and B is non-combustible, limited combustibility and class 0 as per UK norms, and it is classified as class A as per ASTM norms. So this gives you a correlation to understand what is the classification of product you should be selecting as per different norms. So when it comes to iClad, we have tested our panel as per the European norms, and then we have classified it in the category of A2. This is the testing done at a facility where before the test you can see the picture, and after the testing also you can see the picture. There's only soot that is formed on the surface of the panel, but this panel, not the substructure, did not disintegrate and fall off. So A2S1 D0 signifies classification is A2, smoke index is 1, and droplet is 0. Next is UV. We are all talking about UV. When it comes to UV, even if you take the costliest of the costliest products, even if you take a Mercedes car or a Porsche, whatever it is, you will still see that when it's placed on the sun, a bright color is always going to fade. So how do you check whether it is within the limited scale or not? To check the scale, we look at something called gray scale, which is tested as per EN 438 part 6 using an Atlas testing machine. The process is as per code EN 438 part 2, but after the testing process, there's a scale from 1 to 5, 5 being 0% fading and 1 being almost becoming white. So every product in Facade should have a contrast and appearance of more than 3 and 4 out of 5 after 1500 hours of testing in this machine. Now this test is mandatory for any product in Facade irrespective of the nature of the material. So after this testing, what we have observed in our panel is that our scale for contrast and appearance 4 and 4. So this is done as per EN 438 part 2. You can see before the test and after 1500 hours of test, you don't see a significant difference in the surface of the panel. So above 4 and 4 indicates that even if you see the panel through a photospectrometer, you will not see the differentiation in the color. Now let us understand what is sintered stone. Sintered stone is formed from basic raw materials of clay, feldspar, silica, titanium dioxide, and bentonite. Normal tiles are pressed with 8,000 tons of pressure with a certain binding agent for the clay particles to fuse together. Now in kitchen slabs and all, you use something called porcelain slabs, which are 15 mm thick. They absorb lesser moisture. That's the reason you can use it on kitchen platforms. As you can see, there will be a lot of oil stains, especially in Indian kitchens. To withstand that, they go with a material with low porosity. In porcelain slab, the pressure is 15,000 tons. Now, the science says that if you press the product by adding extra content of bentonite, and if you press it at a pressure of more than 25,000 tons, you don't have to add a binding agent, point 1. Point number 2, the porosity becomes almost 0. Point number 3, it increases the flexural capacity of the material by almost 2 times. So, because of this, when the flexural capacity increases, when you have wind load in a high-rise building, the deflections because of wind load in dry cladding is taken care of. So normal tile, if you use it for exterior, tiles are very brittle and hard. So they easily crack. But where if you use the sintered stone, which has a titanium dioxide in the glaze, it will be able to withstand weathering for a longer period of time, and it will not crack because it has extremely good flexural strength. So when I talk about 25,000 tons of pressure, it means almost 2.5 times the weight of an Eiffel Tower. So coming to the next slide. Yeah. So when we use titanium dioxide in the glaze, what happens is when UV light hits the titanium dioxide induced surface, it makes sure that because of photocatalytic process, the dirt and the dust particles are washed out, and because of the super hydrophilic nature of the surface, and it makes sure that it converts SOx and NOx, which are emitted from your vehicles and refrigeration manufacturing, it converts them into harmless polyatomic ions. So literally, if you clad 10,000 square feet of our cladding, it is equal to planting 68 poplar trees, which are more than 20 meters tall. We are also using products like fire stops at dead wall openings, and we use rain screen facade applications to make sure that all the cavities are sealed. Whenever there's fire breakage because of short circuiting or something of that sort from the interior part of the building because of electrocution, the fire breaks in through the window, and because of using this fire barrier, the foam expands and makes sure that it compartmentalizes it and avoids the fire from spreading from the adjacent compartment. So by this way, you ensure that fire is not spreading from one compartment to the other using this rain screen facade. So our system is completely a stress-free system. We use a rear ventilated facade, And the mock-up can be seen in our stall. We can always, probably, if you can drop by, we'll be able to explain you in detail what is the system we are adapting. Yeah, and we 100% use recycled material for packing. We use 100% green fuel, and we use 50% waste is reused and reused in terms of generating heat to fire our kiln. So what we offer, we are a complete solution provider. We make sure that we give you the complete system, not just the product. And we also train our installers and facade contractors to work with us closely. We operate through our authorized channel partners. So Q-Tone Ceramics is formed in 2008. We are there in the industry from quite some time. From 2018, we have been exporting this sintered stone product for exterior facades. We have been supplying to US, UK, Australia, Israel, and also some parts of Middle East. In 2024, we launched it along with the complete system. We are the first to come up in 2018 with the largest slab of 3,600 by 1,200 mm. I will be happy to provide you more information if you can come down to the booth. Thank you for this opportunity. It was a pleasure talking to you all.
Thank you, Aditya. It was very insightful. Now let us call as the next speaker, Mr. Neeraj Nayyar from Viva Composite Panel. Let's welcome him with a huge round of applause. Thank you.
So good afternoon, ladies and gentlemen. Thank you for giving us the opportunity to exhibit, to showcase basically the contribution of metal cladding, product and services into the sustainable building envelope. And when we take the example of sustainable as a word, so how does a metal cladding as a product contribute into the sustainability, into the product environment? So we're going to share following topics. So more than a product presentation, it's a knowledge sharing session which we would like to highlight. And thanks to Jotun, which just presented about the importance of quoting the different standards which we have. So when we talk about the construction speed, which is the prime importance nowadays in metal cladding particularly. So we're going to highlight how construction speed plays equal and important role to deliver the project in a timeline manner. Next is EPD, one of the crucial aspects, and how, taking some examples from the Western world, it is now turning to be a digital product passport. Then the second last, unmatchable expertise what we have as Viva to deliver, to translate the real form to the real facade form. And next few of the project references. Okay. So just to introduce who we are. So Viva is bringing with it more than 25 years of manufacturing excellence, with delivering more than 15 million square meter of production capacity with our 14 plus production lines. We do have a 25 plus warehouses into the country, as well as we are serving more than 40,000 plus customers globally. And not only in India, we do have our global presence where we have opened our offices and partnerships to deliver the India's superiority in terms of delivering the coated products as well as the right quality products. So when we talk about the technical differentiation, so Viva is not only coming up with the product, but also varying comparable to the other products, other manufacturers in terms of technical differentiation by providing the required certifications and the color coating guidelines which AMA has. So this is something like the factors which we try to accumulate when we talk about sustainable solutions. So it has following parameters, talking about thermal efficiency, which deals with the maintaining temperature of the building between outside and inside, talking about recyclability, long life cycle of the product, as well as the durability and the corrosion resistance of the product. All these factors contribute towards the sustainable environment into the building using ACM material. Now the important slide of the session. So the way India is progressing, construction speed is very vital and it plays a significant role in delivering the project timelines. Now when we talk and when we compare about the pre-coating versus post-coating, we have tried to collect several experiences from the stakeholders and try to analyze the importance of reduction in the timelines. And when we talk about the post-coating as well as the pre-coating, so there are series of steps which get involved into pre-coating and post-coating, but the major difference is getting the things executed at different channels and the one single point channel. So thereby we are having expertise. We are a one-point channel which procure the coil, color the coil, coat the coil, fabricate the coil, and produce the installed design as well, so that at the job site we should supply the finished material so that we can reduce the timeline at least by 50% and plus. Non-negotiable factors, when we talk about the speed, definitely the faster installation contributes a lot, enhanced fire safety, versatile finishes, as well as when we talk about design flexibility, enabling our architects, designer to achieve the aspirational designs by upgrading the project timelines as well as the product qualities. So third topic, EPDs. So when we talk about sustainable, the last letter of this word is E. According to me, or I can say like E also stands for environment. So when we talk about environment, this EPD stands for Environment Product Declaration, where EPD is actually the verified profile of the product, which actually captures some important parameters like water, carbon, energy, by which we make the product environment friendly. Coming to this digital product passport, so I had a discussion with one of the global players from Europe. So they used to define not EPD as EPD, they used to define EPD as a DPP. So it's a digital product passport, which actually captures not only the product literature, but also how it gets maintained, how the installation should be done, and it should be maintained over the life cycle. It's a life cycle assessment of the product, which not only gives the product performance, but also helps in achieving the required building ratings. So the one best example, how does the different building ratings of IGBC and GRIHA are useful for us. So EPD for ACP or for solid materials, solid aluminum materials, enable us to provide at least the building rating from silver to gold, gold to platinum by contributing 3 to 6 points as per IGBC, and it also helps us to maintain 3 to 5 points for the GRIHA rated buildings. So this is something which we have to dig down in deep, and Viva has is the only company which got certified based on EN 15804 standard, and the first company in the country which is upgrading the designers to how to escalate our building ratings from gold to platinum, and how we can as a product supplier contribute into the same. So one takeaway in this particular slide using the EPD. So EPD is not simple optional document. It's a regulation. It's something like best standard practice what we have to follow, by which as India is as I've just mentioned, it's a progressing country. So this particular certification is helping us to meeting with the global benchmarks. Second last topic. So as I just mentioned in the start, so Viva has more than 500 plus shades, which is allowing us to transform the real into the real facade. So we have captured a few of the images. So this left side image, if you see, it's almost 1,000 plus years building. It's by Paul Tableau's is one particular earthen structure which we have taken from the European market. And if you see on the right side with our composite material product, with the coating what we have done, the shade, the textures we have developed, enabling us to resemble the real versus the real. One more in terms of wood, the wooden finishes what we have. So it not only gives you the color, the shades, it also gives the texture appearance, the touch experiences. So when we talk about the metal, so being it's rusted steel, being it's a cotton steel, so all different metallic finishes we have come up, and it's not only giving the coating, again the texture appearances. Now on the next slide, and we are proud to have this particular slide where the new invention SolidX, it's a pre-coated solid sheet, where we have tried to capture the real image of our directors and our CMD into the perforated SolidX sheet, which is we have developed so that it's not only the building photographs or the images, but the real person image can be developed using the perforation done on the solid sheet. So these are the following products what we have to offer. We are not limited only to ACP, pre-coated solid aluminum sheet, aluminum corrugated panel, which takes us to not only to restrict to A2, also trying to achieve, and in fact we have our solid sheet with A1 non-combustible fire rating properties. Honeycomb panel, zinc coated panels. So we have a series of the products available in our kitties. These are different series under our brochures. We have defined to basically complete the whole range of the product, bricklane, wooden, natural stone, everything we have. few of the project references. So this one is the example of the Pune-based building where we have done the cladding of more than 28,000 square meter and supplied the product which is tarnish series. And here the architect is Sandeep Shirke and the consultant is Menard. Few local experiences from Gujarat side, from Ahmedabad particularly. So this being Pragya 2, I believe all of you must be knowing about this building in the gift city. So where we have supplied more than 3,500 square meter of the product where metallic dark grey has been used. SVKM Sanad building. So here also we have supplied almost 7,000 square meter of exotic silver, and thankful to the whole team of Viva in the Gujarat, which we have delivered this particular product beyond the timelines in fact. Last, a global experience. So this particular project we have done in Kuwait City. So where we have supplied more than 17,000 square meter of our ACP with the two different shade natural stone as well as with the travertine finish. So just to end, I got a question sometime back, in our stall that can we use ACP material in a high-rise building? So this is the answer for that. Thank you.
Thank you, Neeraj. It was indeed very, very insightful. So we are heading towards the last event of the day. So for that, let us call on stage Mr. Mitul Gajjar, the man himself. He doesn't need an introduction. So I would tell him that he is my Guruji in terms of giving me the knowledge, in terms of techno-commercial things, how to go ahead, how to crack the deals. Because since I've started taking orders, he was the only consultant, he was there. So I've learned a lot of things for him. So let us give a warm round of applause for Mr. Mitul Bhai.
Hello. Yeah, I think audible. I think good evening everyone. I think this is the last session, but not the least. It's going to be a big session, and I think the panelists they are well leading developers, architects, and facade system. So first of all, I'll call the Ingit sir. Please come on stage, Ingit sir. Is he ready? Hello, sir. Yeah, I was waiting for you. Where are you? Yeah, there's a vice president.
Give a warm round of applause to all the panelists.
Thank you, sir.
Thank you.
I'd like to call Mr. Deepak Patel from the director Torgon Group. Please come. Welcome, sir. I'd like to call Nitesh sir. Please come on stage, sir. He's an architect from the Neha consultant. I'd like to call Ms. Namrata, the PMC, from the team PMC. Yes. Welcome, ma'am. Yeah, and last of the list, Mr. Pratik Doshi, National Manager, Shuko India.
Thank you, sir.
Thank you. Well, thank you. So I think stage is full, and I think my topic is that like to start with the main two developers which are sitting here. So I'd like to start with Ingrid and Vinod Bhai sir. How you see this high-rise facade in a gift and in Ahmedabad region, like gift city, how they take care of it, and how you think the facade will in a Gujarat, how will grow? So what your perception from your side? Because you are doing so many projects in Ahmedabad also, and you are doing projects in gift city also, and you are doing in Ahmedabad. So how both the authorities are moving towards this high-rise facade? And as a developer, what do you think on this?
So lately, Ahmedabad, I would say, finally had taken the plunge to go towards the tall building. Other cities like Bombay, Bangalore, all the cities were all building the tall building. Ahmedabad is now getting into that league. Coming to Gift City, I would say it is the concentrated pocket of the tall building. I believe the number of tall buildings in Gujarat may not be equal to the number of tall buildings just in, Gift City. And in Ahmedabad, it's now taking place because a lot of buildings are being constructed and being designed which are over 100 and 150 meters. I think this is just the beginning, and from now to 2036, the trend looks to be very bullish, and there is a great scope for the facade industry, for the real estate developers in the commercial and residential segment. Coming to when we compare between Ahmedabad and Gift City, I think the working style in the Gift City is quite process oriented. It's clearly defined, and it's easy for us to operate in the Gift City. Ahmedabad is again, gearing up for that. So I think the future looks promising for the next 10 years, especially in the high-rise building.
So what do you say about
The future of the facade intensely grow. The facade key element that looking to the future of tall buildings in Ahmedabad, as my colleague has said, as far as vertical growth is going on in Ahmedabad, facade is the basically future. But along with the facade, also we have to consider some other elements like Ahmedabad is a hot city and having industry and all. So along with the facade, we have to consider some fins kind of thing to maintain the thermal efficiency and everything. Yeah.
Further to that, I have to ask that now we have a tall building community in Ahmedabad, and you have a gift authority also, and you have the Ahmedabad municipal. So are you facing any challenges or positive approach from their side? Are there rules or regulations? You feel that further we want to improve in this directions, like a good facade, the firefighting systems, or good aesthetics and rules and regulation? You expect that what is the challenges you are facing, or any positive signs? What do you say about that?
So I would like to comment more on the gift part because our projects are located in the gift city. When it comes to the high-rise building in Ahmedabad, currently we are not doing any high-rise building in Ahmedabad. But when it comes to the gift city, I feel because they are quite process-oriented, they are highly involved in every stage of the building, whether it is from architecture design to structure design. And when we started our project in 2021, that time facade was just one of the components of the building. There was no peer review system for the facade design and for the facade. Now, after I think 2021 or 2022, GIFT has mandated the peer review for the facade design and for the process. So, I feel this as a good step towards the building approval process. I would not call it challenge. When it comes to the fire part, I see the fire department of the GIFT is quite proactive. They have clearly outlined every single stage of the approval, whether it is from development plan approval to during the construction, at the stage of occupancy, and also the regular audit. I think the regular audit part is something which is very important when it comes to the high-rise building. See, the risk associated in a low-rise building, for example, a bungalow or maybe G+4 or G+5, G+7, it is not, the risk is not that much as compared to a building which is 100 meter tall, 150 meter tall. In that way, I think GIFT has anticipated the risks which may come, and they have the risk mitigation process in place. So, I mean, as a developer, we are pretty happy with the GIFT City in terms of, especially in terms of the facade design and facade design approval part, and the peer review, and also in the fire regulations and system.
Sir, what about you saying that what Ahmedabad has to improve? Because the GIFT, because a lot of projects we do, and they have every step verification is there. From start from from the design stage, from the process stage to the end stage, they are always there, and we always monitor that whether you're going right track. So what do you feel that means Ahmedabad also should capture those things, and are we should do better in this, in that direction? Because gift is still a smaller capture in that, it is controllable conditions which can be managed very well, where Ahmedabad Municipal Corporation is a very big setup and it's a bit difficult also.
Basically, building is a building, like either it is in GIFT City or it is in Ahmedabad city, as far as facade is concerned, right? Because at both the level, heat and dust and all is same level. So basically, facade designing has to be involved at the designing stage only, because there are some other components also, like if you are going to do facade lighting, then if you do it later on, then it will be a process, lengthy process and all to optimize the design of facade and everything. So everything has to be taken care at the stage of design only. Right?
On same thing, I would like to go to Nitesh sir. Sir, you are also project having in GIFT City as well as you are doing in Ahmedabad. How this both the agencies like accepting this facade, that we should go from the normal buildings to the high rise and facade, and in going in that direction, because Mumbai, so we are doing so many years back, but now Gujarat is, I think, maybe 6-7 years it's going on. So how they are in positive side, and what are the challenges for you, on making a plot? Because I have seen your presentation, you got a very small plot and then you have to do some miracle in that plot to everyone become happy. No, so I have to understand what your challenges facing is.
First thing, in Ahmedabad, facade is a more challengeable than other state, because our city is a hot climate. So I should say that we should not use the full building with glass. We are making mistake. Only we should use on the north or east side. But we are copying the other country in the facade. So first thing, in Ahmedabad Municipal Corporation, they have a law. In GDCR, you cannot use glass facade more than 50%. And it is totally not followed by any builder or any architect in Ahmedabad. They are not following GDCR. All building is a glass box, and they are not taking they are giving the building use permission to that building. So GDCR is different than GIFT City. Second thing, in GIFT City, you have to design the facade inside the given floor plate. In Ahmedabad Corporation or Gandhinagar, you are getting a 2 feet facade, 2 feet projection for elevation. So you can design facade accordingly, and which is better if I am doing the glass facade and I am putting the curtain, then it is good for the building. So according to my suggestion, corporation is not doing any assessment or any third-party peer review in the 70-meter building. It should be introduced, and they should they should do the survey for the Ahmedabad for how much glass we should use. So according to that, if we should make the changes in the facade design, there is lot of scope of the facade in the high-rise building in Ahmedabad, because in Ahmedabad just now they have introduced 5.4 FSI for the tall building policy. So looking to the Commonwealth game and also bullet train, there is a lot of scope of high-rise building in Gandhinagar, in GIFT, and also in Ahmedabad. So I should say both the laws are different. So it should be, we should try to make the law for both the GIFT City and Ahmedabad should be equal, and they should make the changes in Ahmedabad because everybody is breaking the rules. That is my suggestion. Thank you.
So moving to go in further topics, 3 of the question is that now we have the building rises 165. Where do you think where we'll go? Will go 200 or 250? How you see is a facade will grow in tall building? You think that will go about 200 meter height? I think it's more a kind of builder first of all, because it's expense, and it's a thought process of the developer whether we should go in that direction, because at the moment we have 165 meter height, and that is the tallest one is going on. So you see that the progress in future, that building will go taller and above.
See, when it comes to the building height, there is a threshold. If you go beyond that threshold, you have to comply with a lot of other requirements. Sometimes, it's not, let's say, if I talk about a decade back, 70-meter building, when it came into the existence, people were like fascinated by now Ahmedabad is getting the 70-meter building. But the risks associated and the cost of maintenance and the concerns which are associated with the 70-meter building, they are far more higher than the 45-meter building. When you go to 100-meter, the risk keeps on increasing. Whether the city has infrastructure to take care of all those things, because the moment you do a 150-meter building, 200-meter building, that means on a small plot, you are trying to encapsulate so many people, so many cars. That particular junction will become a influx of very high traffic in terms of human, car, or whatever it is. I think in a high-rise building, it had to be very calculated call given the infrastructure of the city, given the capability of the developer, especially from the maintenance point of view. Nobody is discussing the maintenance point, because right now Ahmedabad is at the junction where tall buildings are being designed, are being constructed for 100 meters, 150 meters. Developer part will get over maybe in 2 years or 3 years, whatever is the maintenance period. But who is going to maintain the building after that? Again, I go back to the same point. Maintaining a building, low-rise building like G+5 or G+10 is a very easy game. A society form a members committee and they take the decision regarding the security or whatever it is, whatever the functionality is. The number of functionalities in a low-rise building are far less as compared to the functionalities. When I say functionalities, fire system, pressurization system, elevators, waste collection system, everything becomes complex. So I think in years to come, Ahmedabad had to gear up in terms of the maintenance game. And when I say the maintenance, it applies to everything. It's also applied to the facade and all those things. I think it's somewhere we need to find the threshold till which level should we really go up. I don't know whether it is 200 or 300, and the 300 meter, 400 meter, that doesn't define the development. The development is the primary governing factor for the development is the infrastructure, then the real estate. So I think that is the most important part.
I agree with Anand, because developer is spending money for his building. In Rajkot, 210 meter height building is coming. It is in the HTC committee, special committee. Our city should be prepared for the infrastructure. I will give you one example in which case I was involved. In that case, ICICI Bank has taken one plot in Gandhinagar, just opposite to NID. It is a story of 15 years old, 12 to 15 years old. It was designed by office contractor. Our company was local designer, architect. When we reached to GPCP for the approval of environment clearance, they have rejected that project, and due to GPCP question and rejection, that project is dropped and land is given back by the government. Why they have rejected? They have asked one question to the designer and to the authority. They have planned more than 3,000 vehicles in that building. It was a 165 meter tall building and back office of ICIC. They have asked, if you are planning 3,000 car or this much buses, just tell me when your timing is fixed from 8 to 5 or 9 to 12. What will be happen in the surrounding road and how traffic will be managed? You just come with that calculation, and in which they are failed, and after all it was dropped. So in high-rise building, a developer or any private or government can spend for the high-rise building, but our city should be prepared for the infrastructure. As Anand said, all infrastructure, drainage, water supply, our road width. In this much small road, you are going to construct 150 meter. Even we will feel on the SC highway after 1 or 2 years, because on the SC highway there is more than 10 5.4 or 150 meter height building, you will see what will happen to the traffic. So not only we should think about the high-rise building, we should think about the infrastructure of the city, and that call should be taken by the government.
I think I'll come back to my subject, which is a glass facade, because it has gone to the other direction. So Pratik, as a Shuko, I know the Ahmedabad is skyscraper is going on. When it's not Mumbai, still it is in Ahmedabad. And challenges are that we want a safe facade, clean facade, leakage-proof facade. So what are the efforts has been done by the Shuko that we should capture in, have a good system in the place, and also it should be that accommodate that yes, we should go towards the tested systems basically. That how the Shuko is taking. What is the process of yours?
I didn't get the question. Can you just?
So what is the process of your developing the system?
Designing the system.
Designing
you mean
system.
To say. Process of designing system for
high-rise facade. What do you do in
high-rise
the
facade. So, sorry, I'm audible, right? So basically, Shuko has done a lot of high-rise buildings worldwide. Okay, so what comes into picture while designing for high-rise building is managing a lot of wind load zones. Okay, now different wind load zones possess different challenges to you, and while designing, what we see is there are the variation between the lower wind load zones and the higher wind load zones is high. So either you plan or design the facade based on the high or low. It depends on the cost and so on. So we design it that way based on keeping the consumption of the material minimum and making it optimum for the project. Now, secondly, what becomes more important is designing the system so that the water leakage and air, the water ingress in the and air permeability becomes it's of high importance, and it doesn't compromises. So in our designing, what we do is the gaskets. The gaskets today, what people see that gaskets are EPDM. That's a check mark. Just making it EPDM doesn't matter. It has to have a design. There has to have a flap of the gasket. And that design should not get compromised when it gets a higher wind load in the negative also. Okay, so in India, what we did 4 years back, we came up with a small test lab. So we can't do wind load testing in that, obviously. But what we do is water testing and air testing we do. And then we go for the final testing of that. This is what we do for any building actually, for even the low rise and everything. Because if I go to a 45-meter building in Chennai, it has 3 kPa wind load. And if I go to a 150-meter building in Ahmedabad, it has a 3.5 kPa wind load above 15th floor. So this designing, we keep on doing it. So high-rise challenges we have. Now, the another challenge is of openable window. Okay, openable window. Okay, now openable window becomes very critical because in Ahmedabad, buildings are not designed like a box structure. People want different style. Okay, everyone has a different look of the building. Building has fins. Now, over here, fins are not for sun shading. It is an aesthetic element. Now, to remove an openable window, to remove a broken glass, facade needs to be designed in that way also so that it can be replaced easily and also doesn't compromise the water and air. It is challenging, and we are also learning. And what we do in Europe or what we do in India are completely different, but the process which we follow is the same. So this is how we are steering through, and we have also successfully done it. Okay, but yes, there are challenges. Openable window should be made in such a way that can be executed also well. I can't make an elephant product which no one can actually tame. So that way we do it. I hope I answered the question.
So that was on the design stage, but then what do you do in efforts to that to have a good fabrication, good installation method of trace, and what is overall your approach on a project basis?
Correct. So whatever we design has to be executable. First of all, that is the aim considered in mind while designing. There is a challenge where at the time of execution, how much you can control. Yes, it's a challenge. I agree with it. And we have also learned throughout the years by actually failing in some parts of the project and then repairing it and then changing the process what we do. So at present, what we do is we manage the quality audits. So we do frequent quality audits, but we are not able to do on-time quality audits because we actually practically cannot do that. So what we do is training again and again, training the team members in such a way that you train them such a way that habit actually comes into the quality habit, that the way to install has to be this. So while we do maybe the training at the start of the fabrication, and while the first 100 panels are being made, at that time we become so strict that the other output we just have to minutely check. Though even after doing such things, we face issues because of the team changing at the fabricator's end. So there comes a part that we have to again start doing the thing depending on the capability at that point of time. Yes. So I'm not saying that we have 100% perfect projects, okay, but we are taking the maximum efforts amongst everyone to actually achieve a perfect project. Okay. Still, if we we can't do it, we again learn, change, and again implement the process. So sorry, I'll just take a minute. So we did a pilot project in Mumbai. I presented that in the Zak Mumbai. In that pilot project, what we did, we hired 2 people, 2 engineers from the industry. We kept 1 engineer in the fabricator's factory for the quality check, and 1 engineer for the quality check at the site. Now, whatever was coming from the factory was quality audited by a person A, and whatever was coming on site was audited while receiving and while installation. We found that we have achieved a clinical site. Okay, it is so clinical that the customer himself says that I have not seen a project like this. But for that, we incurred a cost of around 50 lakhs because the project went on for 2 years, that 2 people dedicatedly work on 1 project. So we have actually offered this to customers that we have did a pilot and it worked. The cost incur is this. If you really want a clinical project, you can actually do this. Yeah.
So now, Namrata, I'll come back to you because you are the center point in entire, whatever process happens. The building starts, you are there. When the piling work is there, facade design, you are there. Even the facade execution and handover. Now tell me, the facade design has been done, the system, the consultant is given. So what initial challenge you face during the the design, tender, and the vendor? What are the challenges you face in the entire process, and how you are going to overcome?
Audible?
Yeah,
It's not audible. I think you can give it.
Hello.
Yeah, you are.
A little bit. Speak a little bit.
Okay. So what happens usually is that whenever we start, the agencies are appointed, we have the contractor on board, we have the system company, everybody on board. Then the real work actually starts. When the site surveys are done, we realize that there are variations in as per site conditions. There are some gaps in terms of design gaps or gaps in terms of coordination, wherein we feel that the miss-outs may be that some supports are required. Somewhere we see that the brackets fall right where the column is placed, and all these things happen. So the whole shop drawing process and site survey process is then taken on the drawing. After that, again a re-verification of the actual site condition is done as per the drawing that now we have figured out. And once this entire process is completed, it usually takes 2 to 3 months after getting the contractor on board. So that 3 months is somewhere everybody's patience is being tested, because the contractor most of the times comes at a very later stage on the project, probably when the RCC is either at 50% or say 10 floors beyond. So, everybody is in that mood that now we need to start the installation. That doesn't happen for at least 3 months. After that, the fabrication and the pre-engineering process of the entire facade system starts. So, the pre-fabrication, pre-construction process of the facade prior to installation usually takes 6-7 months. That awareness somewhere I feel is missing in a lot of places and in a lot of developers as well as the execution team. So, when the panel is installed, that time you have to start calculating that this is the output or this is the speed of the facade installation, rather than calculating it from the day one. So this is a major challenge that we face. Also, there is a lot of when we talk about the scope or gaps in terms of design, if I can just give you an example, the walls have to be aligned with your mullions. This is something, otherwise the mullion is off and you see a wall right outside the glass in the elevation. So these things may not have been picked up right at the design development or the construction phase. They are picked up at the time when the shop drawings are being prepared. So then we cannot shift the wall because a lot of things has already been done, and then the solution is being worked out around what is available, which obviously has some more cost and time to it. So I think early coordination and early or rather I would say early integration of the facade within your main design is something that we should focus on, and consider that facade is not a finishing item. Facade is part of our shell and core structure for high rises, and that's, if we can just correlate it, things will become very, very easy for all of us.
Now, I want to say that key design and versus budget. So, what are the challenges?
Design
versus budget. What are the challenges you face? It's a general question. It's not that I'm saying.
It's a very tricky question indeed.
And I think it goes to the developer also. It's not that you only to reply. It goes to him also. So what is the percentage of facade? See, earlier it was there, when the glass was very less, a part of the building, like he says 50%, earlier it was 40%. So we say 10 to 50% of overall contract should be or a facade. Like if it's 100 crore, 15 crore should be facade. I think that was very old. So now what has happened that today's challenge is, of course, today we cannot say, but now the material cost is increased. So what you, as a developer, what do you think that what should be the facade percentage of the project? Because today now, entire maybe 80% is your glass or 70%. It is not less than 70% glass is there only. Or maybe even the facade duct area also is facade, we can say. So what is the percentage and what are the challenges you face that when you make a design? So during design you consider that cost, or maybe later stage you come to know that no, it's going cost beyond what I have made the design. And because of course there is a process of your 8 to 9 months, and then you feel that what we have done. So because I want to see that gap, because it's always a challenge as a consultant also, that it come back, whatever we did is going beyond our expectation and something like that. So what is your, what should be a percentage, right amount of that?
Well, it's a very good question. Debatable. It could be a long answer, but I'm just trying to keep it as precise as possible. Frankly, you cannot allocate the percentage for the budget for the facade. It doesn't work that way, right? What you can do, what we do in our organization, we do have some benchmark data. We have the data from the past project where, let's say, we have floor to floor height. What is the glass specification? Which kind of glass are we using? Are we going with the system, or are we going with the bespoke system by the other fabricators? So we are able to arrive at some number. Now, to understand that, you need to holistically, if I tell you simple example, you take one panel, explode it, exploded view. What are all the components in the panel? You can get the rate analysis of one panel and you are able to get the budget of that panel. So in terms of percentage, you cannot put, and it will not be a holistic way of putting in that way. It may suffice the need of the budget, but eventually then, you will deviate from that. In the budget, I have to consider 12% of the cost will go to facade, but now my facade is going to 20%. Facade also had to go along with the codal requirement. See, our codes are changing year by year, not even year, even 6 months. So I think it is important to consider the past data. What we do, we consider the past data. We arrive at rate per square feet of the glazing area, not the building area. Again, glazing area, see, lot of particularly in the developer segment, the cost per square feet is associated with the built-up area. Now, built-up area cannot be used in the facade because some building may have 2 basements, 3 basements, longer basements. So I think when you factor in the budget for the facade, you have to consider the glazing area. You have to consider benchmark or the past data. What is the rate per square meter? You have to factor in the inflation, and so that you can get one budget. And then when we start the design, then we have to explore it. So if I say whatever is budgeted, the actual will be same, it's very hard to achieve because design itself is a very evolving process. And the other part is all these elements, look, it's like a plate. All elements are there, but they are not interconnected in the process. So design is happening at one stage, budget is happening parallelly. Or if you decide the budget first and then you say, okay, you will get only 10% for the facade. I think it cannot work like that. You have to consider the benchmark data. You have to factor in the inflation and some other changes, and you also have to keep the provision for what I say, accidental cost. Or if I tell you a very classic example, because the current project we are doing, when we started the design and budgeting and everything, when we were at the stage of awarding the tender, that time aluminum price was 275 or 280 rupees. Yesterday aluminum price is 385. Now it's something that nobody could anticipate it. I'm just saying in the current current situation, which is a very one odd of the situation in the era of the humanity. But otherwise it is you consider the similar system. You need to connect with the facade consultant to give you a broad level BOQ with the entire costing, and that you should keep it in the budget. It cannot go other way around.
What do you say about?
It is residential or commercial, right? Suppose in our residential project, we first of all do the sun pass study in all the seasons. And based on that, we design the facade direction, facade glasses, facade glass insulation capacity, thermal conductivity, everything keeping in mind, we use that. While for commercial, there are two aspects. Like one is how much your southwest side is open, and what is the view you want to explore for your customers and all. So keeping in these two things, as well as the facade should not be a glass box, as I said earlier also. We should have a smart facade, like instead of only a glass cube. So all these parameters, and one more important thing, what my colleague has said is, you should incorporate facade consultant. Majority of the builders or developers are not going in that way. They simply put it in the architect view. So from the day first, you should have facade consultant in.
That is the reason Mitul is sitting here.
No, I was coming to that one, that I am a little bit selfish. Then when you want your facade consultant to be on board, so I asked to do that. You are the core person. You got the challenges because facade is come with a very late stage. Sometimes the facade consult comes very late stage. Yes. No, and it happens sometimes. Sometimes they may be involving from the day one when it's with the design stage. So, and as far as I think I'll ask all of you that when you want a technical guy to be on the place, because when you do a building, you have a structural team from day one. You have MEP from it goes parallelly. But sometimes happens that facade consultant or a technical guy or user maybe internal work, he comes very late, and there are challenges. So as a PMC, what do you feel that what should be there? So it goes very smooth process.
So what happens is that when the architectural concept is freezed, the before the design moves into the schematic stage, the facade consultant has to be on board. That would be the right time, because usually what happens on projects is once your design development is done, tendering is done, projects are on site in the construction mode. Everything in RCC is completed, then the consultation with the facade consultant starts and initial opinions are taken. I am not saying that they are completely left out of the grid. Opinions are taken, but sort of detailed discussion that how is the proposed concept, how can in terms of buildability, in terms of operationally, maintenance wise, also the modularity of the entire design. Are the panels repetitive? Not everything that an architect can vision something, but to put it into the engineering modules, we need the facade consultant. So there are things like everybody knows that the slabs are designed as PT slabs, like you also mentioned in your presentation. So the facade guy doesn't know that the slabs are being designed as PT. They are constructed after 10-12 floors. We get the tenders, BOQs and tender drawings. That when the facade guy says, okay, you will have to do anchors. There's no possibility that we can drill anchors in the PT slab. So then we again do a upstand. We do the rebarring, we cast an upstand. It is a time consuming job. Rather, this thing would have been discussed or coordinated earlier, there would have been either a cast-in channel, or we would have figured out some other way, having a peripheral beam which is non-PT. Something could have worked out earlier so that integration would have happened a lot better. So as I said, when the schematic design starts, that is the right time to involve the facade consultant. Even the lighting design because of facade. The lighting that is required with the facade is thought of at a very later stage. And by that time it is all reworking, or there are some works that are held up on sites. So that detailing can be done earlier. It eases out on construction, and even it would save time of everybody. Even the architects have to reconsider the given drawings. They might have to rework, give revisions. So it's a cumbersome process for all of us. So that would be a suggestion. Secondly, even the vendor should be taken on board earlier. Like maybe when the building reaches the ground floor, because for high rises there are usually 3-4 basements. Like that's a norm these days. So 3-4 basements with the foundation, it usually takes 6-7 months or maybe more to reach the ground. That much time is sufficient for an entire facade thing to work out, to get a vendor on board, and then the challenges can be addressed in more efficient manner.
Yeah, you get enough time for the shop drawings. I think she has answered very well. I see this as a very simple linear curve. The early you appoint the facade consultant, the less will be the implication in terms of design, in terms of engineering, in terms of cost. So it's like a very simple curve. I believe when you appoint the architect for the architectural design, I think facade is a part of architecture. It's not a separate element. So I would say in design development itself, the facade consultant should be involved so that the key inputs can be taken care of by the architect in the initial concept itself. So that when it goes to the schematic, it is more or less filtered, and the design development it is through. And for example, if you appoint a facade consultant later on, then suddenly you may come up with an idea that I would like to do the lighting on the facade. Now, all these things need to be done in the design development. Later on, it is very difficult to take out the provisions, and it becomes a challenging at all levels. So, it's directly proportional to the cost, implication, and complexity in every stage: design, engineering, execution, I would say operation, maintenance, everything.
Even you have to consider the limitation of market also. Like if you are designing 600 mm pins, and later on you are knowing that there is no any drawing machine in India which is drawing 600 mm length. So later on you cut it to 400 or something like that. So that parameters you have to consider at the design stage only.
Your question is good. We normally, when we design any high-rise building with glass facade or other elevation, we introduce the facade consultant from very first day. Structural consultant, facade consultant, and even MEP consultant. Because what happened when we are playing with the mass, on the some area you are getting the terrace, and how to get that rainwater pipe behind the facade. It is also a challengeable. So we appoint the facade consultant from very first day. Even we try to call the all vendors to work out for the cost. Not only the facade, as in our presentation we have showed, normally we calculate the facade cost, but after that, in our case, we have to install for the cleaning, that system is around 1 crore or something. So we have to add that cost into the total cost of the building. In one of our project, which is on the ISKCON Amli Road, it is only 45-meter building. In that we have done, in our presentation, we have shown the cantilever portion is a 30 feet, around 30 feet. And our facade is 30 feet far from the external point. In that, in the design, we smartly introduced the balcony. So cleaning part was omitted, and my cost is reduced. If I go for the facade like curtain wall, it will be more costly rather than putting the sliding door. So it is on the north side. So we have put the sliding door so we can get the light and air also. So on very first day, according to my opinion, facade consultant should be introduced in high-rise building.
Okay, I think go back to the technical thing. Pratik, what do you think that all the facades should have test laboratory test with a tested system, or maybe you should also have intermediate test at site, and even the testing should be done at site. So what is the thought process of and what you should be, because yeah, gift of course it's a compulsory. It is happening for at least a third of BMU test, but also that after that the test is passed, what is happening on site. Second, Ahmedabad is still moving in slowly in that direction. So what your thought process on tested system?
On a system business perspective, my thought process is that whichever building is having a standard typical facade, okay, they should just follow the process, have a good fabricator, and do some corner testing at site. You don't need a performance mock-up for that, because a building which is very basic, a rectangular box building, and it's less than 70 meters, wind load would be 1.8 kPa. Like, we have systems tested up to 3.5 negative. Okay, so I don't think so PMU really matters over there. But if there is a regulation, yes, we honor it. But if there is a building, let's say we did Shivalik Shilp like 10 years now, okay, it had a corner. We didn't do a PMU over there, okay. Like, there were too many things we missed, but still the building is actually perfect, because like, my team at that point of time did a great job in designing the right system. But if someone asked me to do it today, I would do the shop drawing before even procurement, and I would do the PMU of such project, because it is not a standard project. So I feel performance mock-up tests are required somewhere, not in standard, in critical facade, because the fabricators team and the system vendors team actually, they are trained together. They understand what are the nuances of mistakes happen, from where the suction air is leaking, so that they know that at the project I should avoid it. It also helps in training, but it can be avoided for simple projects. This is my thought process. Otherwise, I'm not against. Site testing, yes, there are projects like we are doing projects with Panchasheel at Pune. They do only site testing. Okay, somehow they don't believe the PMU, and I'm okay. They take tested systems from us and others as well, but they do the site spraying of testing, and they are very well going ahead with it. Okay, that is their methods. Whereas the same level of other builders, they follow the PMU and the VMU method completely, how it goes. Yeah.
Okay. I'll come back to you, because when the building is completed, it has also to be maintained. And every time we challenges that BMS system will install, it's always a challenge, and that the cost and whether it will work. So what your process is following, but how you able to deal this? How to deal this, because you are facing this, because the cost of the BMU list. It's the gift is also asking compulsory. Sometimes not. People say we still do with the Spider-Man system. So how the costing is common, and how you deal with this?
See, actually, when developers are ready to spend X, I'm not just figuring that percentage, but say for example X amount in building for the facade. Just imagine that facade not being maintained. We have got Ahmedabad is all tropical and dusty climate we have got. So it's not going to be seen the same way as it was designed or as it was thought of being seen if it is not maintained properly. You may look after it after 2 years and feel like this is not what was intended. So in terms of cost, there is awareness, and I think people are gradually moving towards providing BMUs. Sometimes the constraint is that even after providing BMUs, there are, I would say, non-accessible spaces because of the geometry of the building, where still a spider or a gondola has to be used for maintenance. Otherwise, BMUs in a lot of upcoming projects that we are doing, they are all planned for and they are all accounted for in the initial budgetary cost itself.
So what you see is that the building has to maintain. See, now we thought earlier it was like a structure building, so it was no, there was no cleaning required. Now the entire structure is covered with the glass, so glass also has some maintenance required, and we put the beams. To build this building has to continue for next 25, 30 years. So this cleaning system, it should be a part of, and it should be compulsory. It should be done. What do you say on this?
No, BMU should be the part of, it should be mandated for the high-rise building. Because see, there are two parts to the building, especially with the glass facade. One is the regular cleaning. For that, I think many of the agencies, they do not use the BMU. They have a simple, upchilling system and they clean the building. But when it comes to, let's say, if some of the glass gets destroyed or if some of the glass gets broken, without BMU, you will not be able to change that. So I think BMU, I don't see BMU as a separate package of the facade. BMU is an integrated package of the facade. So it had to be integrated into the package that we have to provide the BMU, and it should be mandated, because otherwise it will be very difficult in case of changing the glass or in case of changing, any component in the facade.
So even we saw that some of the project has been designed without the thought process of how the building will be clean. Once it is in and out, so much in and out, and it has been done in such a PT slab, then later part the system also to be implemented, it's very difficult. And because straight building, we can able to clean very easily, there is no problem. But if you have a building which is in and out, it's very difficult to clean, because eventually building has to look in a good condition and beautiful. Because if you are saying the gift city is the ideal place and where you see good buildings, so it has to be all look building is clean. So I think that should be a part of first stage, that whether we are making this building are going to be cleaned properly or tomorrow or not, because or what provision we need to keep it now and what things should be done.
See, I would put a different approach here. For example, let's assume a building takes 6 months to design. Let's say 1 year to design, 4 years to execute. For what is the life of the building? 40 years. Your decision should be based on those 40 years. 6 months you take for design, 4 years you take for construction. You may do very well, you have the best of agency to do the work. But the remaining 40 years, how it will be maintained, that thought process to come in the design stage. And that will help you to optimize your design, to see your design whether it is maintainable or not. Because ultimately, when you factor in the maintainability of the building, your design thought process will change. Then you will think about whether should I do the offset? If I do the offset, how will I maintain the soffit below? So I think it has the thought process needs to orient in a reverse manner. Life of the building, execution, design.
I think we have done a lot of things. Now you tell me, sir, what is the future of Ahmedabad in facade? Means how you see is a positive, what we should do better, and how we move forward ahead. And that the entire Ahmedabad will come up with a high rise, which is going to be, and how much percent of glass, and still you expect that glass will go further. And what is the thought process? I think I'll go for individual one by one.
See, Ahmedabad is a hot and semi-arid climate, right? If you look at the history of the Ahmedabad, somebody has presented from HCP that Ahmedabad architecture has evolved in a very, in a very traditional manner. Earlier it used to be jali, and then, small opening. There were regions because of the climate. When we see the future of the facade, I would not classify glass, and I would say that the future of the facade should be designed in a way that should be responsive to the climate of the Ahmedabad. Ahmedabad had two major challenges. One is the heat, second is the dust, which is a big problem. And third is, of course, the birds and pigeons. So the moment you provide 40 mm horizontal space, then you should be prepared for the, the worst case scenario. Second, facade, glass facade, because it also increases the ambient temperature because of the reflection. I think there needs to be a good study where there is a balance between solid and transparent. When I say solid, you can put ACP, you can put stone or something, or you can even, divide the facade like half, some part will be in the masonry and dry clad, or maybe like Aluplex has shown one fantastic presentation where they have done the entire facade, where only, I think, 40% of the facade was glass and 60% was the solid. So those kind of things are very much important in Ahmedabad given the climate. The second part of the, I read here also, in terms of residential building, should the glass facade be the part of residential building? Given the cost, given the maintenance, given the cultural fabric, given the privacy, I think glass facade should not be there in the residential building. That is my take. That is according to my experience and my personal opinion. In the commercial building, it can go because probably there is no choice. We have gone too far in the glass now, so nobody is willing to come back. We have adopted the modern architecture. Modern architecture was meant for the European countries, European weather. Ahmedabad has a different weather. I think some of the architects are doing very good work in terms of overhang. I think for the commercial building, even for the normal residential building, I was discussing with our team some days back, even for the normal residential building where there is a window. See, earlier the windows were till chill level windows. They were half windows, I call it in a layman term, half window. Now all the apartments have got the full window. Full window with the single glass is a disaster. I mean, you are just inviting the heat and you are increasing the air conditioning load. Now, typically, a developer may not be inclined to spend the money if there is no awareness. If given the awareness, developer may spend the money. For our project, I mean, in Collated and previously Amar, all the projects, the window had always been the DGU.
Yeah.
To cut down the heat. And it will eventually put less load on your air conditioning. So I think those things should be mandated going forward because look, Ahmedabad year by year is getting hot. Yeah. I mean, April in this year is quite hot than the previous year. So I think we have to, like he said, it had to be regulated. Why things are getting so good in the gift city? Because it is controlled by authority. It is regulated. You are bound to do that. I think we need those systems in a pace that we cannot imagine. But for the next 10 years, Ahmedabad had to implement things very, very fast, regulated way to control the building inside environment and its effect on the ambient environment.
Yes, I think so. I think the already signal has been given to twice. So I think we take away is that as it's, everyone says that we are already ahead in the glass, so we are not going to come back. But simultaneously, we want a good facade, a safe facade. We want a good system because it's life we make for 50 years, and future is Ahmedabad is going to be glass.
Yes.
Hope how we do it. Perspective of using glass in residential or non-residential, that's a separate thing. But the glass going to be a prominent till we get some replacement of that.
It should be high performance glass. For Ahmedabad, the only option is high performance glass given the budget.
That's very true that we want to go one more option. We want a good system like thermal bake system is there. Somebody I think using a thermal bake system we use using. So those systems also be required. And we are doing high-rise buildings, so we want a tested, a good system which really monitor. Once we make, we come out, we know the building is safe, we don't need to worry. We have given sufficient backup of maintenance of the building. What we have done is perfect. There is not going to be leakages, there are not going to fall on the panels. So it's a safe facade and it's a livable facade. Thank you very much everyone, gentlemen.
Thank you.
Thanks a lot.
Thank you.
Thank you. It was an amazing, amazing panel discussion. Thank you all the panelists for really, really insightful knowledge. And although it was a bit over time, but we were still very much involved in it. Thank you for your insights and view. I would just like to end the session with saying that thank you one and all for making part of this wonderful session. Thank you team Zak for wonderful event. And it was such a privilege to be with such a powerful people. I feel that I am already being the part of the skyline of Ahmedabad with such influential people. And I just want to say a big thank you to all the speakers, all of my friends who are here. And let us give a warm round of applause for each and everyone over here. Thank you so much. Once again, this is Shalin Shah. It was really an honor hosting you guys. Let us head out for one last networking session. And we wish you a best and safe travels back home. As in Ahmedabad, we do not say goodbye. We say see you soon again. Thank you so much once again.